بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. الحمد لله والصلاة والسلام على أشرف الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. Good morning everyone. It is my pleasure to welcome you all to the biochar workshop on agro-environmental applications of biochar in the Kingdom of Saudi Arabia. Today we are thrilled to host this specialized technical workshop to highlight the prospects of biochar systems for our beloved kingdom. We are honored to welcome more than 9 national and international participants who will discuss the latest innovations in the biochar industry and its applications. Before we begin, I would like to extend a warm welcome to our distinguished speakers and guests. Thank you for joining us and sharing your expertise. Without further ado, let's get started with the Istidama Center General Manager welcoming speech. Please welcome Dr. Khalid Al-Ruhaili.
السلام عليكم ورحمة الله وبركاته. بسم الله والحمد لله والصلاة والسلام على رسول الله. يسرني ويشرفني أن أرحب بكم جميعا في ورشة العمل التطبيقات الزراعية والبيئية للفحم الحيوي. هذه الورشة تقام ضمن سلسلة ورش العمل العلمية التي ينظمها المركز الوطني لأبحاث وتطوير الزراعة المستدامة لنشر المعرفة وتمكين التواصل بين الشركاء بمنظومة البيئة والمياه والزراعة، وتمكين الزملاء من التعرف على آخر التطورات العلمية والتجارب الدولية الرائدة في تطبيقات الفحم الحيوي في الزراعة والبيئة. يسعى مركز استدامة لتمكين المملكة من تعزيز مفاهيم وتطبيقات التنمية الزراعية المستدامة، ويعمل بالمشاركة مع شبكة عريضة من الشركاء على المستوى الوطني والدولي وفق منظور استراتيجي يراعي الأطر والمعايير الوطنية للاستدامة. يقدم المركز خدماته البحثية والاستشارية والتدريبية والتوعوية، ويسعى لتفعيل وتوطيد الشراكة مع المؤسسات الرائدة وطنيا للاستفادة من هذه الخدمات وتحقيق المستهدفات الوطنية. تهدف هذه الورشة لتوفير بيئة حوارية متقدمة ومنبر لتبادل المعرفي حول الاتجاهات والابتكارات بتطبيقات الفحم الحيوي وتحويل المتبقيات الزراعية من التحدي إلى الفرص، وتكون مورد له إسهامات اقتصادية وبيئية. لقد برزت أهمية الفحم الحيوي كمنتج ذكي له القدرة على تحسين صحة التربة والنبات وزيادة القدرة على خزن المياه، وأيضا دوره في تخفيف آثار تغير المناخي والحد من انبعاثات الغازات الدفيئة وتعزيز الإدارة الرشيدة. يتطلع المركز إلى الاستفادة من تطبيقات هذه الفحم الحيوي في المجالات الزراعية وتدوير المتبقيات العضوية. نأمل أن تسهم الورشة بالتعرف على أولاً التطبيقات الزراعية والبيئية الجيدة والاستفادة من الفحم الحيوي بالإنتاج الزراعي في المناطق الجافة. ثانياً تعزيز الأبعاد البيئية المتصلة بنظم وتقنيات وتصنيع الفحم الحيوي وتطبيقاته. ثالثاً تقييم دور الفحم الحيوي في التخفيف من آثار تغير المناخ وإدارة المتبقيات الزراعية. نشكر شركاء مركز استدامة ونؤكد حرصنا واستعدادنا للعمل المشترك، ونحن نسعى لدعم ريادة المملكة وتميزها بتقديم النماذج الرائدة للإدارة الرشيدة للموارد الطبيعية المرتكزة على البحث والابتكار. أتمنى لكم النجاح والتوفيق في أعمال هذه الورشة، ونشكر لكم حضوركم. Just allow me to say some word in English. Ladies and gentlemen, it is our pleasure to welcome you to the National Research and Development Center for Sustainable Agriculture. It is our honor to have all of you with us here. Thank you for accepting our invitation and contribute to our workshop to discuss the latest innovation in the biochar industry and the application. And please allow me to thank Dr. Catherine. We are very honored, Dr. Catherine Draber, the former board chair of International Biochar Initiative and the director for Carbon Standards International USA. Thank you for coming. She will share with us the latest biochar trend in the innovation for sustainable agriculture. Also, we are welcoming our virtual speaker, Dr. Nasser Khan. I hope he can hear us. from Australia to participate in this workshop. Special thanks to all of our speakers, and we are honored to have you all here. Our workshop is aimed to explore the potential and perspective of biochar system in the kingdom, focusing on the best industrial practice to enhance environmental, energy, and economic outcome. I hope this workshop contributes toward exploring the potential and perspective of developing biochar system in Saudi Arabia, focusing on the best application and industrial practice to enhance environmental, energy, and economic outcome. Thank you for all of you, and I wish you a successful and fruitful workshop.
Thank you, Dr. Khalid, for your heartwarming speech. Next, with Dr. Kathleen Draper, Global Biochar Trends and Innovations.
Thank you. First, I'd like to thank you. I'm honored to be here, and I really appreciate the invitation from the National Academy. And I would like to also thank my friend, Dr. Adil El-Tayeb, who I met, I'm trying to remember how many years ago, but one of the things I've been doing over the last several years, I've been in the industry 13 years now, is trying to find ways to educate different types of stakeholders in the biochar industry. So I've hosted 4 or 5 different study tours to showcase actual industrial applications where it's being produced and used. And I think I met you in Austria was the first one. And then last year I hosted another study tour in Switzerland. So it's a pleasure coming here to Saudi Arabia. And just a little bit more background. I said I've been here, I've been in the biochar industry for 13 years. I came to it from the consulting world and wanted to focus my life on something more sustainable. Throughout the last 13 years or so, I've been focusing on the research side. Even though I don't come from a scientific background, I've worked with Cornell University on different biochar projects, particularly in the dairy industry. And then there's another university near me that I've been working with to use biochar in more industrial applications in the built environment. And I'll talk a little bit about that in a few minutes. So today, what I thought I'd talk to you about is just to give you an overview of what's happening in the industry overall, and then what is driving the scaling of biochar production over the past few years. And then I'll go into what I see as some of the opportunities for biochar production, what's holding us back, because there's definitely some things holding us back, what some of the upcoming markets for biochar are, and then if it's of interest, how do I see the Kingdom of Saudi Arabia potentially becoming a national leader. It's been really interesting to see how quickly certain nations are becoming key players in the biochar industry, some which I would not have predicted a few years ago. So charcoal, or what we now refer to as biochar, has been purposefully made. Let me pause for a second. I had assumed that everyone knows about biochar in this room. Is that a good assumption? Are there any that need a real quick introduction? No, okay, good. So there's a lot of confusion in the industry about charcoal and biochar, and just a quick thing that I always differentiate it between its carbon cousins is charcoal is used as energy for the most part. And we relabeled it biochar maybe a decade or more ago, and that we used to describe a very similar substance made a little bit differently, but it doesn't go back up into the atmosphere. So when you hear me use charcoal, I'm talking about it as an energy source. So we now refer to it in the industry as charcoal. And it's been made by many different indigenous cultures around the world for thousands of years to help improve soil fertility and resilience. And it's only in the last few decades that this link between how biochar can help rebalance atmospheric carbon has been made. This history underscores that converting short-term carbon into highly durable carbon using high heat and low oxygen is not some far-fetched techno fix. It is safe, scalable, and shovel-ready, and it provides a multitude of benefits beyond just carbon sequestration. Once the IPCC acknowledged biochar as a recognized carbon removal strategy, which I think was 2018 or 2019, interest in the biochar industry really started to take off. While it's really very challenging to get an accurate estimate of the current and anticipated global production of biochar, the best guess we have is somewhere in the vicinity of 500,000 tons. I don't know if any of you have read the most recent IBI or USBI survey. It shows just under 400,000 tons, but unfortunately we did not get a lot of information from China and other parts of Asia where we know there is some significant production. So I believe their number is actually low. And if I had to guess, I would say that biochar production is increasing by 20 to 30% or more annually. And that could be higher, except we have a few challenges, which I'll touch on shortly. So what is driving this increase? Soon after the IPCC acknowledgement, the first biochar methodology linked to the voluntary carbon markets was debuted by a company called Puro, and that company is now majority owned by the NASDAQ. Over the past 5 years, at least 3 additional biochar methodologies have been developed by Carbon Standards International, by Verra, and they just announced this past week their first biochar project got approved, and most recently by a group called Climate Action Reserve, which is very focused on the North American market. What's so interesting is that for the past several quarters, biochar-based credits have been by far the largest removal technology when it comes to delivered credits. Yet the price per ton for CO2e for biochar credits remains substantially lower than for other CDR technologies. To date, approximately 12 million metric tons of carbon removal credits have been purchased, and only 3.5% of those purchases have actually been delivered. But the majority of that 3.5% has come from biochar-based credits. I know you can't read this, but I'll just point out that these are the top. This is from a company called CDR.FYI, and they keep track of the buyers of credits, the sellers of credits, and they differentiate between the sellers of credits and those that have actually delivered the carbon. So this is their most recent leaderboard, and all but one of these are biochar companies. And the one that isn't, it's called Running Tide in the middle, they just went out of business because there aren't enough buyers for the credits. But interestingly, the top is a company called Exomed Green, and they're from Bolivia. So Global South is actually leading this trend. The rest are mostly from North America, which is pretty surprising to me because I consider Europe to be a little bit ahead of the US when it comes to biochar production. So this has been a key factor in growth in the biochar production, particularly over the last 2 to 3 years. It's attracting project developers, investors, and credit buyers to learn more about biochar. It's also enabling the price of biochar to be reduced, in some cases, to zero. More on that in a moment. That said, I do believe a fair amount of caution is needed for new entrants to the biochar industry that are predominantly banking on carbon credit revenues. I say this for a few reasons. The number of entities buying any sort of CDR credits is tiny right now, really only a few dozen companies. They're responsible for buying a huge percentage of the purchases to date, with Microsoft being by far the largest buyer. With so few buyers and a growing number of biochar producers, there's increasing competition to sell credits, which puts downward pressure on the prices for those credits. Also, the over-reliance on this single revenue stream is highly risky, given how new this voluntary carbon market is. Earlier this year, I was asked to review a few dozen biochar producer proposals for credit buyers, and nearly all of them were heavily reliant on, or even wholly reliant on, the carbon revenues, and claimed that they would simply give away the biochar. Not only is this harder than most producers envision, since most farmers still have not even heard about biochar, and getting something for free has put many farmers in a difficult position if that free soil amendment comes with unknown toxins, as we're beginning to learn is the case in the US with sewage sludge laced with something called forever chemicals. So giving it away for free to a select few farmers willing to host demonstration plots and help develop case studies for different crops is a great short-term strategy. Giving it away for free forever is not. It's leaving money on the table, perhaps even a lot of it. Valorizing the physical product reduces the financial risk and hopefully enhances the sustainability of biochar production. Even in the past week, I've seen companies that have been getting big news stories about them because of their carbon credit purchases. They've folded, and it's because they haven't built demand for the product. The carbon markets are not the sole driver of biochar scaling, fortunately. Another key driver, at least in some parts of the world, is the need for improved waste management practices for a wide variety of organic materials, including sewage sludge, manure, waste from large livestock operations, urban green waste, and even things like textiles, diapers, and food waste. All of these can and are being turned into biochar, at least in labs, if not yet at industrial scale. Carbonizing these waste streams offers a number of benefits to waste managers, not least of which is a significant volume reduction of between 75 and 95% in a matter of hours or even faster, depending on what technology is chosen. Recent research is showing how pyrolysis can also eliminate a broad range of toxins, including something called PFAS, antibiotics, dyes, and more. These toxins can not only increase the cost and carbon footprint of current disposal methods, but they can incur long-lasting environmental damage to landscapes and surrounding landfills. Another observation I'd like to share is that those in the waste management business have some very relevant experience when it comes to biomass handling and creating market demand for upcycled organics, such as compost for livestock, from things like brewery waste. A case in point is a waste management company I visited last December in Dubai. They set up a small demonstration at a huge camel dairy farm with 8,500 animals to convert camel manure, which was previously being landfilled, where it was not decomposing due to arid conditions. They were making this into biochar. This small biochar production facility was set up in record time. I was really, really impressed, and I think that this can be attributed to their familiarity with biomass handling technologies and finding new markets. Although they were completely new to biochar, it seemed well within their wheelhouse, which is not something I can say I've seen in project developers that have been focusing on afforestation, reforestation, and other carbon projects. Waste managers are often paid to take in and deal with problematic organics, which has a built-in financial advantage as compared to biochar producers that have to pay to secure long-term agreements for biomass. In some parts of the world, like mine, forest fires are actually a key driver for scaling biochar. And I know how counterintuitive that sounds, but the US Forest Service has been funding biochar research and education for at least the past 5 years. Why would they do this? Well, forests in the US, like in Canada and Australia, have not been managed well for more than a century, really since the colonialists took the land from the indigenous tribes long ago. They had learned how to control forests using something called controlled burns. Forests and firefighters are now very interested to relearn how to do this to mitigate the number and the fierceness of forest fires. So turning excess forest thinnings into biochar and leaving it in forest soils to improve soil fertility and resilience is now just starting to be adopted as a cost-effective mechanism for reducing fuel loads. Reducing air pollution is another key driver for biochar scaling. In parts of the world where crop burning is still a common practice, particularly in Asia, there's huge interest in carbonizing versus open air burning. But biochar can also help reduce pollutants going into the air from incineration plants, biomass and coal-fired boilers, smelters, wastewater treatments, landfill, and more. There's even one technology company that's working on, whoops, was that a timing thing? Working on capturing CO2 from pyrolysis to be injected into the ground, similar to direct air capture and carbon sequestration. Many countries and industries are aggressively scaling their renewable energy capabilities to reduce emissions, and they're also wanting to become more self-sufficient when it comes to energy. So gasification and pyrolysis can play a role in this in many cases, particularly when the feedstocks are relatively dry to begin with. Europe has been a leader in this, where the heat is being put into district heating systems. In the US, this is not quite so common, so we're not as good as utilizing the excess energy, but we're starting to make that happen. And it really helps with the economics. So where specifically are the opportunities for scaling biochar production? Within the waste management arena, I think both sewage sludge and large-scale manure management can offer significant benefits, both economically and climate-wise. As more contaminants of concern are identified, particularly those known as forever chemicals, and are found in increasing quantities in sludge, wastewater treatment facilities, are in search of better, safer alternatives to land application or composting and even anaerobic digestion, particularly as regulations for handling these toxic residues gets more demanding. Rapid and significant volume reduction to help reduce emissions and cost of disposal is important as well. Germany and Denmark, I would say, are pioneers in this arena, but it is beginning to be found in the US and elsewhere. Livestock farms are also a really key area, especially in the US. I'm involved with a demonstration project in upstate New York with Cornell University, sponsored by our state research and development group, that is measuring all of the methane reduction related to having pyrolysis at a dairy farm. So this particular dairy farm has about 2,000 cows. They already have an anaerobic digester, but the issue is that that digester is not doing a good job with reducing volumes. You still have a significant amount of what's called digestate left over. So we're co-locating pyrolysis with an anaerobic digester to carbonize the digestate, and then we are using some of that biochar in the digester to improve the quality and the quantity of the methane, and then we're using the biochar either as bedding within the system or as a fertilizer, or we're trying to create local demand for that so that the farmer gets some revenues. One of the key learnings that we found so far is that, at least in US dairy operations, farmers don't really have the bandwidth or the expertise to run a pyrolysis plant. It was the same finding they found with anaerobic digesters. So we're trying to create joint ventures that make sense for a third party to come in and manage these technologies and apply for the carbon credits and develop markets for the biochar. So it's a complicated situation. I think there is a lot of potential in it, but there are some things that still need to be worked out. Anything related to forestry, such as sawmills, paper mills, and forestry management, as I mentioned, is particularly interesting. In the US, I would say this is one of the key segments that's growing rapidly because they don't have a lot of markets for the offcuts from sawmills, and they have a use for the heat. Again, they're challenged because they don't know anything about agriculture or biochar, so they have to find partners to help them understand what to do with all of this biochar that's being made. It was the same thing with the forests. They have a lot of material. They have these mobile systems, which I think I showed in a previous slide. So these are really nice systems where you can take whole trees that are relatively recently cut, take them up into the forest so you don't have to move things to a production facility, but what to do with the biochar at the end. So for the moment, most of this is remaining in the forest, which is not a bad thing, but it's not a high revenue generating area either. Another area that we're seeing a lot of interest, particularly in the US right now, is in post-disaster recovery. As you may have heard, in the last month, we've had 2 enormous events that have generated huge amount of biomass, which generally the current method of disposal is to cut it down, chip it up, and send it to a landfill where it will emit significant amounts of methane. So I've been working with the Federal Emergency Management Agency to look at bringing in some of those mobile containers to quickly and effectively dispose of at least the wood debris and potentially even get some carbon credits from it, which I think in the developing world, in places like Pakistan, could be a way of financing some of this post-disaster recovery activity. Finally, I just wanted to say one of the fastest and most economical ways that people are getting into biochar production is taking existing biomass energy plants and optimizing them or tweaking or converting something at the back end so that it generates, instead of ash, biochar. And there's at least one company that has been in the boiler business for decades, and they are going to all of their clients and saying, here's how I can help you make your process more efficient and produce something that we will help you get carbon credits for, as well as develop demand locally for that biochar. And I think this is a brilliant strategy, but it doesn't work everywhere. One of the companies on the leaderboard, a company called Pacific Biochar, was the pioneer in doing this about a decade ago. And they have huge biomass energy plants in California that they have now converted to produce maybe 10% by volume biochar. And they're making a lot of their money on the carbon credits such that they are able to give away the biochar for free right now. Which sounds terrible, as I said, but they're giving it to landfills right now. And in the beginning, I was a disbeliever, but what it's doing at landfills is helping to reduce odors, it's helping to reduce leaching, and it's sequestering carbon. So, and it's helping to reduce methane as well. It goes without saying then that the biochar industry has faced our fair share of challenges, which have prevented even more scaling. Education is probably one of the biggest challenges, though we've been making a lot of progress over the past few years. But with so many new stakeholders coming into the industry, what's difficult is trying to prioritize which ones to focus on in terms of education. So IBI, where I was the board chair for 4 years, we decided to focus on those coming into the industry on the biochar production side. Entities like the US Biochar and the European Biochar Industry Consortium are helping to educate policymakers and end users to create demand for the biochar. I think the biggest challenge for the last 5 years, at least, especially as this scaling has been happening, is finding markets for the biochar, given how few people have still even heard the word biochar. So I'm going to talk about a few promising markets shortly. And it's very variable around the world. I found in the US, we have very different markets than what they have in Europe, and it's probably going to be the same here. I think one of the reasons we're not finding good markets is we don't have enough case studies in specific types of agricultures. And I think this is something here in Saudi Arabia, it would be a good thing to start getting students to focus on different types of agriculture and developing the economics around what amount of biochars, what types of biochars make economic sense, as well as what are the other emission reductions that occur. One thing, and I'm not really sure if this is considered a challenge, but there's an endless market for something that looks a lot like biochar, but it's charcoal. And most companies that I've talked to are finding that the steel industries, the metallurgical industries will buy all of their biochar to co-burn with with coal. And they're doing this to decarbonize, which is a good thing, but it is not going to qualify for credits. It's not really sequestering carbon. It's still a good thing to do, but it's hard to move away from this consistent, constant demand. Over the past few decades, agriculture has been the primary focus for most biochar researchers and for prospective markets for biochar. In the early days, it was often the case that biochar research focused on maximizing the amount of biochar used in soils to optimize carbon sequestration. But this made the economics for farmers especially challenging, at least for many types of crops. Nowadays, the research and on-farm case studies are much more specific and supportive of targeted biochar use that is much more cost-effective. As you'll hear from the speakers that follow, some of these are very applicable to growing constraints experienced here in Saudi Arabia, such as improved water management. This is one of the first areas of growth in the western part of the US, as droughts have significantly impacted orchards, vineyards, and other crops. And now that is one of the biggest buying groups within the US for biochar. Mitigating salty soils and restoration of desert landscapes has also been garnering more interest in sub-Saharan Africa and other coastal areas impacted by rising seas and more arid climate. In other parts of the world, you see this a lot in Latin America, where fertilizer costs are high. Farmers are embracing biochar as a means of reducing their reliance on increasingly expensive fertilizers, and the major multinational buyers of some of their crops are further encouraging this due to the reduction in associated greenhouse gas emissions from the production and use of fertilizers. Farms in the developed world are also facing increasing regulations around the timing and amount of fertilizers used, given the negative impacts on local waterways, such as harmful algal blooms and fish die-offs. Other agricultural markets for biochar in some parts of the world include feed additives, which I think you'll be hearing about soon, bedding, manure composting, where it can significantly reduce methane emissions by up to 80%. And it's starting to be used in combination with anaerobic digestion, where, as I mentioned, you can carbonize the digestate. Outside of agriculture, there's a growing number of soil uses, most notably for stormwater management, restoration of former mining sites, and even in landfills, where I said it's reducing odors and leaching. Stockholm, Sweden, this is a depiction of their structured soils. They pioneered the use of biochar in urban tree planting more than a decade ago. And the original reason they were doing it is to extend the life of trees and the resiliency of trees. But what they found as an additional benefit was that it increases the speed that water can infiltrate into the soils and how much of the water can go in there. And it actually filtered some of the toxins from the roads and the roofs. So this led to decreased demand on their wastewater treatment systems, and they have since then gone well beyond just using these structured soils around urban trees, but they're using it in walkways and everything really as a way of improving their resiliency to storms. Oh, sorry, I'm going to go back there. I don't think it was Yeah, so I wanted just to mention in the petroleum industry, one of the more recent projects I've been working on is exploring how it can be used in and around abandoned oil and gas wells to plug the holes and then to remediate around the wells. This has already been trialed in a few locations in my state, New York, and it's undergoing further research. And what we've been looking at is putting it in the concrete at the bottom of the pads and then using it to displace clay to fill the holes. Again, this is a way of sequestering carbon safely. And then I've also talked to a number of different petroleum companies about putting it around pipelines. In the north where it's cold, this is a way of providing some thermal backfill, but also if any of those pipelines leak, it's a way of absorbing any leakage, and what we want to try is seeing if it can absorb any methane leaks. But that research hasn't started yet, and it would be a good area of research here if there's interest. In the last few years, there's been growing commercial interest in using biochar in building materials. And this is something I wrote about in the book Burn that is out there. It's particularly being commercially used right now in concrete and asphalt as a way to lower the embodied carbon material of these products. They're advancing in Europe. The pavement here is from the Netherlands. This is a picture on the top left here in a skate park. I don't know how to use this. It's not working, where they used it in the concrete here. They're also using it in insulation, which I think is very clever. This is a company in New York on the lower right that is putting it in structured insulation panels. And their idea is that you can retrofit existing homes with this very climate smart, high insulating material. There's a builder in Colorado that's using loose biochar between the floor joists, I think they're called, here. Oh, geez. I don't think this is working. As a means of humidity control and insulation. And then this is a picture from my house in upstate New York where I put it in my plaster. So there's all sorts of interest and ideas where it can be used to lower the carbon footprint. The challenge here is that in many of these materials, the price of the material that you're displacing, in the case of concrete, it's often sand. In the case of asphalt, it's low-cost aggregates. The price of biochar needs to be low. And what we're finding is that some of the buyers for these materials want the carbon credits with it. So that can be challenging. It's not impossible, and in some places that have regulations to use low-embodied carbon materials, this makes an awful lot of sense. We're not there yet in the US, so we're struggling to find the right biochars where it does make sense. And in the case of things like sewage sludge, where you're being paid up front to manage that material and can give away the biochar for free, this makes a lot of sense. And it's great because these are enormous markets by volume, if not by price. So later on, I brought up a few different building materials that you might want to look at, some of which are not really building materials, but they're composites. And one of which I wanted to point out was made right here in Saudi Arabia. This is a bioplastic, and is Mohammed Tariq in the room? No. Mohammed was one of my students last year. I held a 2-week academy in upstate New York, and we had 2 people from Saudi Arabia come, and he sent me one of these samples. And he works for a food company, and they're looking into using biochar made from, I think, poultry litter waste within their system. So it's a great concept. And then other examples here are biochar bricks and recycled plastic with biochar, and I even have a little sample of camel dung biochar in case you're interested. So I don't have time to cover all of the emerging markets for biochar, but another one that is gaining momentum is in the filtration market. Often the materials used in filtration is activated carbon, which is quite expensive and comes with a heavy carbon footprint. So your biochar will most likely have to be specifically designed to harvest or pull out whatever it is that's in your particular wastewater. And whether this is considered carbon sequestering or not depends on what you do with that biochar that's saturated. Very often it's regenerated, which means thermally treated. In that case, you're not really sequestering things. But if you're harvesting things like nitrogen or phosphorus, it then can become a slow release fertilizer added to soils and can be considered carbon sequestering. So I don't really have time to cover this. This is something I did about 8 years ago, and I think every company going into biochar production and every country going into biochar production should create one of these. The Australia-New Zealand Industry Council just did a much better advanced version of this, but what it's doing is looking at various potential markets for biochar. It's looking at how much could you sell into that by volume, what price point are you likely to get for the biochar for those end uses, and how ready are you? So again, I'm just showing you this as something that I think would be really interesting to develop here. So the last thing I wanted to talk about is some suggestions for a few ways that Saudi Arabia could become a leader in the biochar industry beyond just producing biochar. And again, I don't know if this is a goal for people in this room, but I hope it is, because I think we need more biochar champions all over the globe. So the number one thing I think companies or countries should be doing is looking at how to get biochar added to their nationally determined contributions and into their detailed decarbonization plan. To date, there's few, if any, that have officially recognized it in their NDCs. And just last week, Denmark was the first country to acknowledge that they're developing a decarbonization plan specifically for biochar, and I'm visiting them next week, and I'm hoping that they may share some of their lessons learned as to how they got that far, and maybe even host a workshop on how to develop these national decarbonization plans for biochar. Beyond sequestering carbon, biochar can help reduce emissions in a myriad of ways, from reducing emissions from the production and use of fertilizers, as I mentioned, to needing less of it, and reducing emissions from organic waste. Developing a national level framework for how biochar can help with all of these things has yet to be done, and it would be exciting and inspiring game changer within the climate space. I also think, although I think you may have started a national biochar association or a regional association to provide education to the variety of stakeholders coming into the industry, and maybe even host some more education or a study tour here. And finally, I mentioned briefly, I think more and more trials need to be developed with case studies that demonstrate the economics. I'm working on one of these with Cornell, and every month we host different stakeholders and show them, what the operating model looks like, what the cost savings are, what the different technologies are. And I think these are one of the best ways to get people interested and educated quickly. So with that, I have about 3 minutes. And first of all, Adil, I wanted to ask you what else you might want me to mention that we talked about yesterday, if I forgot it. Good? All right, then there's a couple of minutes for questions, if anybody has any.
We'll have a discussion now.
Okay. Well, then I yield my 2 minutes and 42 seconds.
Thank you, Dr. Traber, for your fruitful presentation. Next, we will have a presentation harnessing biochar benefits for agro-environmental sustainability with Dr. Adel Abdel Noor.
السلام عليكم ورحمة الله وبركاته. أرحب بكم جميعا، يعني حضور نوعي وتحيات نبرر لكل الزملاء من كامل المراكز الوطنية والزملاء من القطاع الخاص ومن الوزارات ومن كل الجهات. سعيد كل السعادة بهذه المشاركة، و it's very challenging to be the next speaker after Kathleen. I'm going to try my best. Kathleen, be prepared that you will hear some few words in Arabic. We will use some words in Arabic. Okay, harnessing biochar benefits for agro-environmental sustainability. حاولت من خلال هذا العنوان يعني ألامس ما هي الاحتياجات الحقيقية التي نحتاجها نحن في المملكة من هذا المنتج الذكي. يعني في تطبيقات صناعية حكت عنها، في قضايا أخرى، لكن مركزين أكثر على الفوائد والاستخدامات في الزراعة وفي البيئة، وحتظهر في المياه كذلك. في كثير من الأشياء ما حأرجع أعيدها لأنها ذكرتها دكتورة كاسلين. The power of biochar to enhance sustainable agriculture هي متمركزة highlighted in blue: soil and water management, agricultural organic waste, sewage sludge management, CDR climate change, greenhouse gas emission, smart animal farming. يعني هي حرقت علي كل الحاجات، لكن I'm gonna try to cover again من زوايا مختلفة. ايش يعنينا نحن الزملاء معنا الدكتور عبد الله الراتشي مدير الR&D وزملائنا في كل البحث، ايش يعنينا نحن في استدامة في قضية الفحم الحيوي؟ We are especially concerned نجاوب على هذا التساؤل: how to get the most of biochar to benefit Saudi agriculture. عندنا ongoing project حقيقة بنتعامل مع 4 معطيات، هنستخدم الرقم 4 كثير. في فيد ستوك، في مواد خام من مصادر مختلفة عضوية، صح؟ في بايروليسيس رياكشن، يعني في نوع من التقنية. يعني أنا أفتكر لو ما في مانع أنا أعرف ما هو البايروليسيس. PYR معناه فاير، حمد الله من النار، معناه حرارة. ليسيس جاي من الانحلال. Pyrolysis is a thermal decomposition of organic material in a closed environment in the absence of oxygen. ده التعريف، عشان احنا نعرف انه عملية الانحلال الحراري هي عملية حرق ولا التفحيم زي ما يسميها الدكتور الوابل للمتبقيات العضوية في غياب الأكسجين. لازم نكون عارفين هذه الحقيقة. حقيقة ال4 أشياء عشان أكملها تاني، نحن عندنا فيد ستوك ماتيريال اللي عندنا عدد من متبقيات من مصادر عضوية مختلفة. different sources حنشوفه بعد شوية. عندنا pyrolysis reaction و pyrolysis conditions في مدارس كثيرة في عملية الانحلال الحراري. في slow pyrolysis reaction, fast pyrolysis reaction, في flash pyrolysis, plasma gasification, etc. at a time يمكن قبل أكثر من 15 سنة في أحد المحافل كانوا بيتكلموا عن إنه البايروليسيس رياكشن والبايوشار is a baby industry، يعني ناشئ أو يتطور. No, now recently I don't see biochar as a baby industry. It's a well-matured industry، وزي ما ذكر الدكتور كاسر هو scaling up بمستوى واضح جدا. طيب نحن عندنا البايروس رياكشن نمرة 2. نمرة 3 عندنا الان برودكتس. نحن عندنا 3-4 منتجات تطلع من عملية البايروس رياكشن، اوكي؟ واحد منها البايوشار. عندنا الاذر برودكتس، محتاجين نعرف هذه البرودكتس ما هي المواصفات القياسية لها. We need to have standardized biochar, standardized whatever, even vinegar الخل الخشب اللي هو أحد المنتجات لابد يكون عنده مواصفة محددة عشان نمشي بعده للاستخدام. المكون الرابع اللي هو ما هي الاستخدامات. What is the most appropriate uses of these end products. مرينا في 4 مراحل: feed stock, pyrolysis reaction، جينا عندنا منتجات، عندنا استخدام محدد للمنتجات عشان يجاوب على هذه الأسئلة، إنه هو يتوافق مع الضوابط البيئية وكل المؤشرات. أوكي، نحن we are in a process to evaluate pyrolysis condition for dead palm waste and animal manure. طبعا تعرف انه ديت بالم ويست around 1 متريك طن، 1 مليون متريك طن، 34 مليون شجرة، كل شجرة تنتج 30 كيلو في العام، الناتج حوالي مليون أو أقل. Next في objectives how biochar contributes to water conservation in dry farming. في كلام كثير صح؟ يمكن أستاذنا بروفيسور عبد الرب الرسول سمايلينج وحيغطي المسألة دي in depth، لكن it is worth إنه إحنا ناخد ما يلينا للدراي فارمينج في أشياء قد ما تناسبنا. نمرة 3 how could biochar enhance soil and plant productivity of selected field crops. وفيل كروبس احنا بالتحديد عندنا مسعى فينا نشتغل على القمح بالتحديد. اذا في احد الزملاء في القاعه عنده اهتمام بالفيل كروبس والابلكيشنز بتاعت البايوشار في القمح he is highly invited to be part of the team. finally عاوزين نشوف اسهاماته في المتبقيات الزراعيه والحيوانيه. طيب في الووتر كونزرفيشن فيري جنرال انا هحكي عن انه في improve water retention holding capacity حكت عنها، efficient water use and improve soil structure، drought resistance بيساهم هو في النباتات المتحمله للاجهاد، في الويست ووتر تريتمنت والسيوج ستوك مانجمنت، في تفاصيل كثيره عندها علاقه بالكونتامينانت ريموفال، وهو يسهم في الالترناتيف تو اكتيفيتد كاربون. هذه القضيه بالتحديد ذكر الدكتورة كاسن انه في الدنمارك في شركه مع واحده من المراكز البحثيه حولت السيوج ستوتش الحمى وانتم بكرامه حولت الحمى الى بايوشار. البايوشار عملوا له فيرزر بروسيسنج عشان يحولوه لاكتيفيتد كاربون. الاكتيفيتد كاربون طبعا بيستخدمون في نفس المحطه صح؟ يمتص الروائح والغازات وغيره وغيره. الاشكاليه في البايوشار المنتج من السيوج سلودج عنده السوشيال ستيغما، يعني صح؟ القبول المجتمعي لانه انا استخدمه مثلا في النخيل او في غيره حيكون واحد من التحديات. عندنا لها مقترحات يمكن نحتفظ بها نحكيها لاحقا. طيب انا امشي هنا في الدراي فارمينج نفس الكلام اللي اتقال قبل كده، الووتر كونزرفيشن وبايوشار كان ميتيجيت كومبايند ايفكتس اوف دراوت اند هيت ستريس ايفن حتى سالينيتي، وبايوشار امندد كومبوست عندنا متحدث من استراليا حيحدثنا من ديبس في هذه الفكره. واخيرا عندنا يوتيلايزيشن اوف وود فينيجار از بلانت بيز انسكتيسايد، يعني نحن نتحدث عن انه عاوزين نخفف في استخدام البيستيسايدز. انا افتكر في مدخل كويس في انه هذا المنتج في تايلاند وفي دول كثيره في نتائج حوله انه يحقق كثير من عنده افيكاسي في بعض الحشرات. صور حاولنا من خلالها ودي ريال سيناريوز، انه هنا على اليمين مع الفحم الحيوي ومشرقه كده وفلاشنج كده ومرتاحه، وعلى اليسار في اجهاد حاصل. ما احتاج تو ريبيت. ميتيجيشن اوف كلايمت تشينج، ويست مانجمنت هنحكي عنه، انرجي، سويل امبروفمنت. انا برضو بحكي في الانرجي شويه، انه في خصوصيه في سعودي ارابيا اذا كان نحن عندنا بوتنشال لسعودي ارابيا كان بروديوس 12 مليون بارلز بير داي. نحن عندنا ابوندنسي في التراديشنال والفوسل انرجي. التنافسيه بتاعت البايو انرجي اللي فيها لونج بروسيس وكلفه وتعقيدات ايكونوميكالي حتظل ليس اتراكتيف. كيف نهتم بها؟ دي مساله تحتاج يعني ريجوليتوري ايشوز عندها علاقه بدعم من حكومه او من بعض الجهات. طيب دي اصناف مختاره من الاورجانيك ويست اللي بنتوقع انه بايوشار ممكن يشكل احد الحلول لها. نحن لا ندعو بانه all agricultural waste to be converted to biochar. not that. واحد من السيناريوهات we need to apply life cycle assessment scenarios صح، ونختار انسب واجمل الخيارات التي تتوافق مع اعتبارات كثيره. النخيل طبعا احد الاي سي ار دي، فروت اند فيجيتابل، الريزيديوال فود ويست اللي هو جزء من الاورجانيك ويست هنشوف في الشريحه الجايه، كوميرشال ويست، انيمال مانيور، سلوتر هاوس ويست، سيوج ستوز اند ويست فروم اكوكلتشر اندستري. مايند يو الزملاء في سيرك بعض هذه المكونات remain to be untapped resource. اقصد ايش بانتاب؟ انه ما طالت اي درجه من الانترفنشن لريسايكلينج او ريكفري او ري يوز وات ايفر. انتاب بعضها يعني بيكون في مجهود في ان تسبريس هيلث اند بيولوجيكال هازاردز، يعني حكايه المسالخ وكده، ولكن ما في استفاده منها. طيب municipal solid waste في المملكه 80 بليون متريك طن بريال. يمكن الزملاء في السيرك لو موجودين، اذا في تحفظ على الرقم المصدر موجود. بركبتها MSW اللي هي انتاج الفرد الواحد من النفايات المنزليه 1.7 كي جي بر دي، ده في الرياض. في مناطق اخرى مستوى الدخل ينخفض، ممكن تكون 1.3 1.15. اورجانيك ويست تو ان اورجانيك نسبته 55 ل 45 او 47 ل 53 وات ايفر، لكن اراوند انه عندنا ابندنسي، عندنا وفره كبيره جدا جدا بالمتبقيات العضويه كجزء من النفايات المنزليه. 6% 6% annual increase، هذه الكميات تزداد سنويا. current recovery rate 10 to 15%. عندنا أكثر من 160 لاندفيل في المملكة. بعض من هذه اللاندفيل، مش بعض، موست، أو يعني عشان أكون دقيق يمكن يكون في حوالي 10 ل 12 انجينيرد لاندفيل اللي هي فيها تبطين وكده كده عشان نحافظ على حبس الملوثات وكده. أخيرا في مستهدفات بتتحدث عن 2035 إنه نسبة التدوير في المخلفات المتبقيات الزراعية تكون 100%. 35 around يعني around the corner. أوكي. أنا دوما منزعج من قصة النخيل، منزعج أكثر من الحريق، وصفه واحد من الممارسات الغير رشيدة، واللي هي أبر رانينج شغالة في كثير من المزارع كواحد من السيناريوهات الحلول. متبقيات زراعية كثيرة يتم التخلص منها بهذه الطريقة. في فرصة لنا نحن، هذا التدرج الجميل يلمح لأنه في خيارات لإكستراكشن of different standard of charcoal and biochar solution. Again, biochar itself كواحد من الكربون فاميلي مهم جدا جدا. نحن بنستورد شاركول، نحن بنقطع الغطاء النباتي عشان ننتج شاركول. اوكي. It is good نحول المخلفات العضوية والزراعية إلى شاركول. برضو قصدت إنه الكومبوست يظل متوفر، يعني نحن we should not overlook composting باعتباره واحد من السيناريوهات المهمة للمتبقيات. هنا في الكربون فاميلي ما حنقيف كثير، في different feed stock، لكن في الأول لو شايفين charcoal biochar activated carbon، يعنين الكوست نمرة 4. شايف $، 2، 3. يعني when you take biomass into charcoal في قيمة اقتصادية، when you take it to biochar تتضاعف. لو مشت لactivated carbon حتبقى more and more. القصة على اليمين دي الفلوس والريالات معاها الخضرة، أنا أفتكر ملمح جميل فيه إنه في قيمة اقتصادية. ده جانب مهم جدا جدا. حكى الدكتور كاسن عن الميثين ايميشن ومصادره. بيفتكر الميثين ايميشن في الأجري فود سيستم مصادره الرئيسية 3 أو 4. نعتمد على ال3. أول مصدر رئيسي مزعج فيه جدا جدا الانيمال فارمينج. أوكي. التجشؤ، نعرف بيربينج ان انجلش، بيربينج، كميه من الميثين يطلع من الانتستين بتاعت الانيمال. المصدر الاول انيمال فارمينج اللي هو الميثين يجي منه. المصدر الاخر يجي من السيوج ستولج ويست ووتر تريتمنت بلانت. المصدر الثالث يجي من اللاند فيلينج بتاع الاورجانيك ويست، الغذاء الفود ده لما نعمل نطمره يتولد عنه الميثين بهذا الحجم. في مصادر اخرى في الكاتيجوري الرابعه. biochar remain to be one of the solutions to curb، شوية يخفف أو يحد من قصة الميثين ايميشن في الكتل فارمينج. هذه الشريحة أنا عاوز أتحدث عنه في المملكة في نت زيرو كاربون جولز، عندنا مستهدفات محددة. البايشار يظل واحد من الأدوات اللي ممكن تحقق لنا هذه المستهدفات على مستوى sustainable waste management، على مستوى sewage sludge، carbon sequestration، reducing greenhouse gas، renewable energy and economic benefits. بالمناسبة تعجبني جدا الصورة بتاعت اننا نستخدم كده المؤشر عشان نخفض على اليسار، نخفض الإيميشن. طيب معنا الدكتور ناصر عودة هيحكي عن هذا الأمر، CDR والكربون دايوكسيد ريموفال. I will not talk about. عنده علاقة بالكربون كريدت. ومايند يو نحن في المملكة عندنا من شهر 10 2022 we have voluntary carbon market. يمكن اللي عندهم فكرة بعدين في النقاش يحكوا لي عن الشركات ال 14 الشغالة في الأسواق الطوعية لتبادل الكربون. أوكي. عنده علاقة رئيسية بتحقيق مستهدفات رؤية المملكة، ويساهم في مبادرة السعودية الخضراء لو في زمن الغطاء النباتي، سعودي جرين انيشيتيف بادلي ان نيد اوف بايوشار. بايوشار ممكن يساعد في استزراع الأصناف الغابية، في المياه الهامشية، في مناطق whatever. الهدف 12 من أهداف الأممية التنمية المستدامة، والهدف 13 اللي عنده علاقة بالكلايمت تشينج. جميع هذه الأهداف بايوشار حاضر بقوة فيها. صورة ملهمة. خلينا نمشي للشكل الرابع. يعني احنا عندنا بايوشار فور سويل اند بلانت هيلث، عندنا بايوشار فور ووتر كونزرفيشن، حلول للمتبقيات العضوية والزراعية، وجرين هاوس غاز ايميشن. علاقته بالاقتصاد الدائري معلوم انه هو احد الادوات. IBI remain to be one of the best platform for education for biochar. Casting have been struggling too much to deliver too much education material, and I hope we could find more and more from casting for Saudi Arabia. Global market 600 مليون. أنا أفتكر رقم مناسب إنه الفحم الحيوي يكون حاضر بهذا الرقم الكبير. ما هو الماركت شير عندنا إحنا متواضع جدا، برغم إنه إحنا عندنا حاجة as long as الابندنس الوفرة بتاعت المتبقيات العضوية اللي ذكرتها. فولنتري ماركت كاربون حكينا عنها. بايوشار الكاربون ريموفال برضه دكتور نصر حيكلمنا عنه. أنا هنا بس عاوز أحكي في التشالنجز، أفتكر دي أهم حاجة. ما هي التحديات عندنا في اننا نتعامل مع البايوشار برودكشن and application. We need to encourage some kind of collaboration among stakeholders. أنا ذكرت الأكاديمية هنا كبيرة بالأسود في الصورة. عندنا عدد من الجامعات في نفس الجامعة، كلية العلوم الزراعية عندها أكثر من قسم شغال، كليات الصيدلة العلوم، عدد كلية الهندسة في كمية من industrial applications civil ware كله عنده علاقة بالبايوشار. We need to consolidate efforts. We need to harmonize our research interests. Regulatory agencies عندنا أحد الزملاء عنده تجارب مع شركة يستورد بايوشار، طالبات سلطات الجمارك فيه إنه يرجعوا باك، قالوا تعيد تصديره. اجتهد عشان يمشي يجيب البيبرز والإذن ما أعرف يسموه إيش، يعني في permits، يعني في requirements. We need to encourage regulatory agencies to consider biochar as one of the solutions وننظم المسألة، وتزود إنه يكون في regulations. industry and business. هل البيزنس كوميونتي والاندستري interested وعندهم capacity إنه to scale up this industry in the most standardized way؟ أنا أفتكر دي المشكلة. تحت في الأسفل يا جماعة جبت تاني الأربعة أغراض: different feedstock, different pyrolysis condition, different standard end product, different uses للend products. We need to be very careful not to produce waste from the waste. يعني إذا أنتجنا حاجة ما عندها ستاندر وما عندها ابليكيشنز وما عندها قيمة اقتصادية وما عندها قبول في السوق، يبقى this is أفتكر يعني نونسنس. لكن I don't think نحن من النوع ده، عندنا قوة وحاضرين بقوة فينا ننتج ستاندردايز بايوشار. وأنا تحدثت مع دكتورة كاسن في إنه هل نستطيع أن نعمل نوع من دراسة الخصائص ويست كاركترايزيشن لكل الأورجانيك ويست، ونعمل بروجكشن سيناريو لأنه إذا مرت عن طريق البايروس كونديشنال إكس بتنتج ستاندردايز برودكت واي عشان نستخدمه في الاستخدام المحدد. We are ready to do that. the floor is openly others. Cirque may be in the interest, would like to see Cirque more and more engaged in this kind of industry. Scaling biochar industry calls for coordinated efforts. هرجع تاني أتحدث عن لابد من تضافر الجهود والتكامل والتنسيق بين الأجهزة التنظيمية، بين المؤسسات البحثية، بين الاندستري. وأنا أفتكر thanks for your attention. Always black is beautiful. Black is beautiful.
Thank you, Dr. Adel, for your humorous presentation. Up next with Professor Dr. Abdul Rab Rasool Imran with using biochar to conserve irrigation water in sandy soil of Saudi Arabia.
كيف أحرك هذه ولا؟ أوكي. السلام عليكم ورحمة الله وبركاته. First of all, I would like to thank the organizing of this workshop on biochar and the use of biochar mainly on agriculture. I'm gonna talk about, I think Dr. Kathleen and Dr. Adil didn't leave for us things to talk about the biochar itself and the characterization of the biochar and how to produce the biochar. My presentation or my concern is a water conservation. Can we use this biochar to conserve water in agriculture? And this is very important aspect or very important problems here in Saudi Arabia. I came from a farming background. My grandfather and my father is a farmer, so we from Al-Hassa, so that's why I really concerned about the water conservation. As you can see, the using of biochar to conserve irrigation water in sandy soils. And from the title, you will see that my concentration is on water conservation and irrigation water management in the sandy soils. Can we do something on that or with using biochar? So I will move from here. It's kind of an introduction a little bit and characteristics of our sandy soils here. Why is the soil amendments type of amendments that we use in order to conserve water? In the last 40 years, I was working on polymers, clay deposits, and finally the biochar. I would like to thank also here my former student and my colleague, and later he became my boss, Dr. Muhammad Al-Wabil, who introduced to our department the biochar as in terms of soil chemistry and fertility. So we took the biochar from them and we started doing some kind of, can we use the biochar in water conservation? I'm gonna touch on the result of so many experiments and papers that we published on the subject, mainly in the laboratory, and then we moved to greenhouse and to the open field studies to prove that we can conserve water or not by using the biochar. Why do we use basically the biochar or the soil amendments? You know, probably most of our soils are sandy soil with these characteristics. I'm not going to read that. You can see it's low fertility, high pore, low water holding capacity, and so on. So the question is, and the consumption of water is very high. Okay, you see they can't hear. All right, I will do that. Get closer to the microphone. Is it possible to reduce or to conserve that much of irrigation water you used in the kingdom by introducing some soil amendments or not? That was the main question when I started research on soil improvement or soil physical aspect of sandy soils. In terms of soil amendments, the questions always to be asked in order to mitigate or to reduce the characteristics of sandy soils in terms of soil water management or water irrigation management. What are the questions, or what we need, or which kind of amendments that we should have? Can we these are the questions I put in my research, and some of these are already mentioned by Dr. Kathleen, the amount of the biochar, for example. I will add one thing for that, is the particle size of the biochar. If you want to really dig deep, you have to go and see what is the size of the biochar that you will add to your soils in order to conserve water. So I list of questions, and all these we investigated that in the lab and in the field in order to come with a good conclusions of the use of biochar. Of course, these are for a general soil amendments, but what we did that in the polymers and the clear deposits and in the biochar too. These are some of the, in terms of the polymers, this article that we published in Soil Science Society of Journal, in American Soil Society Journal in 1987, long time ago, when I almost after my graduation. So we work on gel forming polymers to do that. Of course, we find, we find out that the evaporation with the gel forming condition compared to control, we reduce the evaporation. The water will be held in the soil itself, so that we don't lose it, especially in the soil columns with a depth of 30 centimeters. And then we move to another work. It's in the greenhouse. So I will go quickly probably in order to cover all the slides that I have. So it's the same thing. The control has higher evaporation or higher compared to the treated one. Then we move to a clay deposit quickly. Clay deposit, same thing. We took it from Eastern Province or from the Western Province, as you can see, and we use that in our experiment to conserve irrigation water. And these are some of the characteristics of clay deposits. As you can see, the maximum water holding capacity is 90% smectite. That's why you have a very high water holding capacity here. These are some of the experiments that we run in the field and in the greenhouse on the use of clay deposits. Now, we go to the biochar. What are the benefits? Mainly, can we improve the soil physical properties? This is my concern. Can we do that with the biochar? These are some from my hometown. Days bands in Hafuf. Probably some of you saw those pictures before. This is how they collect the waste of date bands. Same pictures. Justification is the use of biochar that from date band can be beneficial in order to conserve water or not. This is our objectives. Some of the experiments that we done, it's biochar by itself. Then we use biochar with compost, and we use biochar also with polymers. So these are one of the experiments. Quickly, how can we prepare the biochars in the laboratory and in the field? This is how we did it. These are of the this is a experiment of the biochar with different rate and with compost, and should mentioned here with the different temperature, because this is very important with the pyrolysis system. How this is very, especially with our soils here, most of the soils, calcareous soils, and we noticed that, or the people in chemistry, with my colleague Dr. Muhammad Al-Wabil, that with the high temperature you're going to increase the pH. So, and we have a calcareous soil. In order to improve the soil, you might just deteriorate the soil further. So we done that at different temperature, and what I mentioned is different particle size. Very important to do that too. And we noticed that also influence of biochar on cumulative evaporation from soil columns. As you decrease the size of the particle size, you will have a better, you can conserve the irrigation water in the sandy soils. Biochar and physical aspect. At the end of the experiment, we usually have a soil water content, and you can see from the columns, the solid one is a control, always have less water content compared to the other treatment with biochar from the figures. And as I said, we took also this experiment in the greenhouse, and this is as you increase the biochar, you have a higher, is taller even the plant with the biochar. This is, I think, done by many people in using the biochar. This is myself, long time ago, of course, when I was younger than now. And these are the work in the field, some of the pictures of using biochar in the field with the deficit irrigation also. These are some of the results on, for example, impact of biochar on hydrophysical properties. As you can see, as I mentioned, cumulative evaporation and infiltration with biochar at low particle size. You have always a lower infiltration rate and infiltration, because this is also one of the properties that we have to measure in order to keep the water in the top 30 centimeters or so, and compare that. These are the sweet peppers yield and the quality as affected by biochar and compost, soil amendments under partial root irrigation system. We use different irrigation system too in order to manage or conserve water. This is with Dr. Abdul Aziz Al-Harbi from the plant production department. Effect of biochar with compost on soil physical property, soil physical quality indices. Same thing as you have biochar and compost was beneficial than biochar also by itself. But I'll repeat that with sandy soils, it's better to have a particle size less than 1 millimeter in order to have an effective water conservation. This is, I think, hydraulic conductivity. As you can see, the control is very high compared to the other treatment with biochar. And one of the aspects also, this is what we are looking for to reduce the hydraulic conductivity of the soil to conserve water. Quickly, biochar and compost effect on a sweet pepper grown under partial root drying system. These are the results. With the same thing, you have a compost by itself at 2% and 4%, and biochar and the combination of them, we have with the higher with a combination of both biochar and compost. Significant biorelative temperature, particle size, and all, the most important parameters we measured. We have this in a paper on the application rate in improving hydrophysical properties of calcareous sandy soils. Almost the same thing that if you have a biochar, you're gonna have, but with the less or at least less than 1 millimeter of particle size of biochar, you will have a reduction in hydroconductivity and so on. We use also not date ban, we use a conic harvest too on that, and it's almost the same trend that with the control you have a higher evaporation and higher infiltration rate, and with adding biochar from conic harvest you will have a less of that, and you can conserve water definitely by adding the biochar. These are some of the infiltration and the cumulative evaporation. Same trend with different. Dr. Hisham Ibrahim, who with us here, he is the first author of this article, and on using also conic harvest biochar. So I think my time is almost the effect of biochar application. We use also different milling in order to come with a lower or nano biochar of that. So these are the result of the experiment. Evaluation of biochar with SAB polymers. We'll go to the conclusions, and these are the latest of our papers on use of the date ban biochar in order to improve soil physical properties. These are on agriculture. And in conclusions, there is only one more. I think I will repeat what I said, is in order to conserve irrigation, really, you have to find the right amount of the right rate, because you might, if you increase the rate, you might have a negative effect on soil water management. So one important thing is the rate of biochar that you will add to your soils. Secondly is the particle size of the biochar that you produce. And thirdly is the temperature that you produce the biochar. Is it 300, 350, or 400? This is the range that we recommend to in our soils, calcareous soils. If you go higher than that, you might have a negative effect on other aspects, the chemical part of the soils. So these are the three things that we have to be considered in our research or in our application, real application of biochar. And I will stop here because I think time is running out, but I'm willing to have any questions from you. Thank you very much.
Thank you, Professor Abdurrab Rasool, for your enlightening presentation. Up next, Dr. Nasser Auda.
Assalamu alaikum. Good morning. Thank you very much to Istidama for inviting us for this presentation. I'm Nasser Auda from King Abdullah Petroleum Studies and Research Center, CAPSARC. So we heard very interesting presentations this morning from Dr. Kathleen on the global trends, and we heard from Dr. Adil and Professor Abdul Rasul on basically some research needs, research results, and applications. So now I will focus on basically linking biochar to net zero, and what we need to do in the Kingdom of Saudi Arabia in terms of decarbonization. So really, the title of my presentation is the role of community-scale biochar systems in carbon dioxide removals and achieving negative emissions. My experience, I'm a chemical engineer by practice, but my experience is for 20 years is in consultancy in the UK and carbon capture, utilization, and storage. In the past 10 years, I've been focusing on negative emissions. And my experience with biochar started 5 years ago with the community scale system for the UK government, which I will be talking about shortly. So CAPSARC, we recently started a program on carbon dioxide removals. How does it work? This one? This one? Okay. So the agenda for today is really talking about carbon dioxide removal, as I said, and then focusing on the role of biochar, then highlighting some applications, which has already been done by the previous speakers, and finally some conclusions. It is evident now, following the Paris Agreement in 2015 and following the IPCC report in 2018, that we cannot achieve net zero without carbon removal. Carbon removals, CDRs, or sometimes referred to as in the UK as greenhouse gas removals, or sometimes negative emission technologies, basically removing CO2 from the atmosphere, whether directly or indirectly, to reduce CO2 concentration. So now it is evident that reduction of CO2 is not by itself enough. We need to remove it. There are several technologies. Biochar is one of them, which I'll be talking about later. But a recent study at CAPSARC found actually that we need, by 2060, which is the net zero target for Saudi Arabia, we need to remove 250 to 370 million tons of CO2. Now, obviously, if you deploy more renewables, if you deploy more energy efficiency, then that target will be reduced. But at the moment, based on recent study, we need to be removing carbon at that level by 2060. So that is a significant target to achieve. You will see in a minute what the available technologies. But many countries now are developing their CDR strategies. For example, Germany earlier this year, they declared they will define a negative emission target. So this is really becoming more and more common in the non-determined contributions for different countries. So now we understand there is a need for CDRs, but what is a CDR? It's very important. There's a misunderstanding usually, what constitutes a carbon dioxide removal process. We need to consider the source, the sink, as well as processes in between. The source needs to be atmospheric air. For example, when you're talking about fossil fuels, if you're capturing carbon capture on fossil fuel, that's not CDR process. It needs to be on a biomass process. Direct air capture, which is taking CO2 from the atmosphere directly, that is a CDR process, a negative emission technology. CO2 stored in biomass and then biomass conversion combined with carbon capture, that is a CDR because you're capturing the biogenic content. It's only at the level of the biogenic content where you can consider it to be a CDR. So if it's 50% biogenic content in the biofuel, then the CDR contribution is 50%. The other principle, again, and this is in the latest report which CAPSARC were co-authors of by Oxford University, it's called the State of CDR. The other principle is we need to consider the sink. It needs to be a permanent storage. We usually talk about geological storage, which is tens of thousands of years or hundreds of thousands of years. But we also can, concrete, for example, using CO2 in concrete or in aggregates, as we see here. All of these are examples of permanent storage of CO2. So the sink is an important element. And also the processes in between. Principle 4 here in the middle, upstream emissions. For example, if you are bringing the biomass from across the world, bringing it all the way to the biomass plant where then you apply carbon capture. That is not very sustainable. So sustainability is an important element. The source of energy used for DAC, for example, for direct air capture, whether it is renewable or not, that makes a big difference. And finally, one of the principles, and important principles, which you will see in that report also by Oxford University, is it has to be a result of a human intervention. So existing forests, for example, absorbing CO2, that's not CDR. It is actually afforestation or reforestation constitutes CDR. So now there are, biochar is one of the key elements. There was a study which is published only last week by CAPSARC. It is on basically the feasibility and potential of CDR technologies for Saudi Arabia. If you go to the CAPSARC website, you will see this study. And we have done an evaluation of what is applicable for Saudi Arabia. Everybody talks about DAC and direct air capture, but then are there other options? There are nature-based solutions, agriculture, forests, soil, storage CO2 in rocks, for example, enhanced weathering, which is now at the moment is at the research, in the research phase. But there are nature-based solutions, but also engineered solutions. These are geological, storing CO2 in geological formations like DAC and BECCS, but there is also biochar. The benefit of biochar, or basically you need to look at the permanence, as I was saying earlier. So in terms of biochar, the research shows 100 and 1,000 years of storage, of potential for storing the carbon. Well, for example, when you talk about nature-based solutions, tends to hundreds of years. So permanence and durability is an important element in terms of what you define as a CDR process. Currently, there are 2 gigatons of CDRs worldwide, mainly afforestation and nature-based solutions. Only 1.3 million tons of engineered solutions. And the majority, as Dr. Catherine said earlier, are actually biochar. If you look at this website, I see I have a link at the bottom there, CDR.FUI, the majority of sales in terms of credits are biochar credits. So biochar is doing very well. And it's at the top in terms of engineered solutions. But another advantage really of biochar is in order to deploy DAC and energy from waste with CCS, because what this study from CAPSARC, the study which was published last week, found out, actually energy from waste with CCS can contribute to negative emissions in the kingdom. There's not a lot of biomass available, but energy from waste, there's currently legislation in the kingdom to divert from landfills to energy from waste incineration plants. That's an opportunity to install carbon capture and to achieve negative emissions or carbon dioxide removals. But the advantage of biochar is that we don't need these large, complex CCS infrastructure. It's going to take time to develop that. It's very expensive. It's going to take time. You can do biochar. These are community-scale systems which you can deploy immediately right now. The technology is ready. So this is one way of actually kick-starting a CDR industry, if you like, or a negative emission industry. This has already been talked about, but biochar production basically is a pyrolysis process, and we heard already about slow pyrolysis versus fast pyrolysis, and the temperature is a very, very important factor, the residence time in the pyrolyzer, as well as, for example, the type of feedstock. But various feedstocks can be used with pyrolysis equipment to generate syngas, which is usually combusted to generate electricity and heat, and then the production of biochar. 50 to 70% can be stored in the biochar, depending on the feedstock, on various elements, on the process parameters. So most of the systems currently being deployed are actually systems for generating electricity and heat. If you do slow pyrolysis, the idea is that you want to basically generate biochar, as opposed to maximizing syngas or oil production. So systems already exist. So the technology, as I said earlier, already at the TRL above 8. Systems exist in Europe, in Switzerland, Austria, and the US. Many countries are already installing this. As you can see from this, some of these systems are, again, for producing syngas, but others are focused on actually achieving these negative emissions and biochar, like, for example, pyrocore. From these systems, just a review of the literature, these systems are small systems, yes, from a few hundred kilowatt electric to several megawatts. They use various feedstocks, including municipal solid waste, energy crops, and so on. And they range from 700 to 4,000 tons of biochar production. So relatively large, but they can lead to significant negative emissions. One system which was developed recently, and this was a patent which we developed for the company, now putting my other hat on. This is called the BioCus system, where I used to work for Ricardo Energy and Environment, where actually we patented this in the UK, and now we are trying to patent it in the US. The idea is that this is a hybrid biochar plus CO2 production system. So basically, we can actually deploy small-scale systems for producing biochar, but at the same time, when you combust the syngas, capture the CO2, and then use that in situ. For example, in concrete, for concrete curing, you can use it in greenhouses, but that's not going to give you negative emissions, obviously. So you want to look for applications where you get negative emissions. Excuse me. So community scale systems like that, obviously you would think that because you are scaling down, the capture of CO2 will become very expensive. The reason why this is attractive is because of the price of biochar, because you can sell it at a high price. But also the carbon dioxide can be sold at a higher price. And you don't need to compress the carbon dioxide as you will have to do with, for example, transporting it in a pipeline. So these systems, as long as you have sustainable biomass, as long as you have a local CO2 demand, and the biochar demand, for example, agricultural installation, this can be installed in agriculture, where actually you can use the biochar on land for soil reconstruction, for other applications, compost, and so on. But at the same time, you can utilize the CO2. So this is the advantages at the bottom here. These are the centralized systems. Obviously, and again, as I said earlier, it's decoupling the need for large and complex CCS infrastructure. And obviously opportunities for local biochar demand, as I said. And then we have done just a quick high-level evaluation in terms of what would be the potential for biochar in Saudi Arabia. Just considering, for example, assumptions, just very high-level assumptions on what feedstocks are available in terms of also a yield rate for biochar and so on. And you can see from this actually that you can basically achieve 8 to 10 million tons of biochar currently, based on current volumes, increasing to around 13 to 18 million tons by 2050. And considering maybe, in comparison to the world global potential of biochar, this is insignificant, obviously. It's because, biomass availability and so on. But this is a big potential in terms of the 370 million ton target of CDR, which we need to achieve. If you consider what the negative potential here is, about 4.4 to 8 million tons currently, rising to, we'd estimate 6 to 12 million tons by 2050. But I just have to highlight a point here, because when we talk about CDRs in general, we're talking about a national target for Saudi Arabia. So there will be competition for the feedstocks. I mentioned earlier that our analysis shows actually DAC will play the main role. Direct air capture will play the main role in terms of CDRs, followed by energy from waste with CCS, then followed by biochar. But there will be a competition between energy from waste with CCS and biochar in terms of the feedstocks. So the target will still be the same. If you take these two together, then do you use the feedstocks for biochar? Do you use it for energy from waste with CCS? That needs to be taken into account in evaluating what the current potential is. At CAPSARC, we're doing this kind of research. We're trying to advance it further in the next couple of years. And obviously, the idea of us coming here is really to try to find ways of collaborating with others, finding ways where we can collaborate on more research ideas related to biochar and others. And also in terms of costing, again, DAC, as we all know, is very expensive. As you can see from here, this is for current systems, $400 to $1,000. This is the y-axis, dollars per ton of CO2. Energy from waste with CCS is around the mark of maybe 20 to, again, goes up to $400 per ton. But biochar at the moment is showing very competitive. In terms of what's reported In the literature, it's 10 to 345 dollars per ton. Our analysis for Saudi Arabia shows around 105 to 360. This is made up of the feedstock cost as well as the cost of the processing, like the utilities you need, the water, and so on. Okay? So yes, I mean, there are various, I mean, we have already heard about the various applications for biochar. You know, I mean, this Audi building in Germany obviously is using biochar in its construction. It's a very famous building, but obviously it can be used as in blocks, as in construction material. It was mentioned earlier to using it as asphalt, and also using it in basically in pavement construction and so on. Obviously, the previous speakers have given a lot of details on this, so I don't have to go into much detail. But one thing I would like to focus on is what I was mentioned earlier, Dr. Kathleen, is about the wastewater treatment sites. There's some synergy between biochar plants and wastewater treatment plants. I mean, obviously, recent findings and recent research, and I'm sure many people in this room would know more than I do about the research of using biochar in wastewater treatment plants. It's emerging research, but it shows that actually you can increase the biogas yield by using biochar in wastewater treatment, right? Because it's an adsorbent, it adsorbs, and so it gives you more biogas. Now, there is synergy between placing a biochar plant where you can, obviously using the sewage sludge from wastewater treatment plants into the biochar, and then using the biochar back into the wastewater treatment plants. I mean, what we are doing at CAPSAR currently, this is really our main focus, is try to advance the ideas and innovation around the circular carbon economy, where you can actually, capture different elements, resources, use it back into the system. I mean, I would say about the biogas system I mentioned earlier, the electricity, heat, biochar, and CO2 production, is that actually many of these, and maybe in the future there will be industry in the kingdom, and we are really certainly recommending that at CAPSARC, where actually you will have biomethane plants producing biomethane, so biogas separating the CO2. So there you will have CO2 being produced, and combining that with the biogas technology which we showed earlier, then you have even a better idea for circular carbon economy, producing carbon dioxide, commercial grade carbon dioxide, producing biochar, and using it back into the system, and so on. So really, in conclusion, and in terms of the different CDRs, biochar is currently the more advanced. Really, the technology is ready. It can be pushed forward to contribute to negative emission technologies. As Dr. Adel mentioned earlier, there is currently a voluntary market in the kingdom as being established. In 2023, last year, the greenhouse gas certification and offsetting framework was launched. So this allows for both carbon reduction as well as carbon removal. So really, this is a big step forward. We need to provide guidance, obviously, but worldwide there is established certification, greenhouse accounting. I mean, if you look at engineered versus nature-based solutions, with biochar it is easy to monitor how much carbon comes in, how much carbon comes out. So this is is being stored. So that's it's ready in terms of MRV, and the majority of current engineered CDR credits being sold globally are biochar. So this is a hint, really, that actually, biochar is well ahead of other like DAC and energy from waste. There is a promising innovation I mentioned earlier, and maybe by actually starting with biochar. Obviously, biochar are small systems. They're not going to help us achieve this big target of CDR we need in the kingdom. I mean, 371 million tons by 2060. Maybe with energy. Biochar is not going to help us achieve that. We still need DAC. We still need BECS, energy from waste with BECS. We still need other nature-based solutions and so on. But what the advantage of biochar is that it can help kickstart the CDR industry. I would be glad to answer any questions. Thank you so much.
Thank you so much, Dr. Nasser. We're going to have a 15 minutes coffee break now. Thank you so much. Ladies and gentlemen, our esteemed guest, welcome back. We're going to continue the presentation now, inshallah. The next presentation, the effect of biochar on the environment, with Dr. Basil Al-Hilali.
Bismillah ar-Rahman ar-Rahim. First of all, I would like to thank all the attendants and also Istidama Center for this invitation and to allow me to speak about the environment impact of biochar. I believe it's I came after break, and this is very difficult to handle the thing. By the way, I will try my best to do something, my presentation on my favorite hope as a theater actor and director, but I hope I will succeed. خلينا بكمل بالعربي. البرزنتيشن مكتوب بالانجليش بطبيعة الحال حسب توصيات الدكتور عادل. أنا ما أدري وش بقول كإنترودكشن. أنا كنت محضر إنترودكشن للبايوشار، اليوزز، طريقة التصنيع، التاريخ إلى آخره، كمدخل لي في بعض المشاكل اللي ممكن تظهر كريسك فاكتور في جراء عملية التصنيع وعمليات الاستخدام، وختاما الرولز الحكومية الخاصة بمصانع إنتاج الفحم الحيوي. لكن بعد المقدمات الأساتذة اللي قبلي، يعني أنا خلوني أقولها بشكل بريف سريع، لأنه الواحد ما يعيد بعد قامات كبيرة جدا. كانترودكشن، حسب التعريف المبادرة الدولية للفحم الحيوي، هي عملية إنتاج الفحم أو المنتج صلب من تحليل كيميائي باستخدام بيئة قليلة الأكسجين أو تكاد تكون معدومة. إنتاجه بيتم من أو مصادره بشكل أساسي عندنا اللي هو النباتات أو مخلفات الأشجار، المزارع، الويست ماتيريال اللي طالعة من الحيوانات كشكل سماد أو روث بعد معالجته بطريقة ما. اللي بعدها برضو الأغصان، كثير من الأشياء هذه بالنسبة للحدود الزراعية أو المخلفات اللي ممكن تطلع من الناحية الزراعية. وهي بالمناسبة بتكون بالنسبة لنا بنراها أنه كبيئة، بنراها أنها هي الأكثر أمانا في بعض الأشياء، المواد اللي ممكن تظهر معانا في المنتج. مثل ما ذكر محاضر قبلي أنه ما نبغى ننتج ويست من ويست، فهذا الشيء مهم جدا. فهي الأكثر، خاصة أنها عضوية بحتة، فهي الأكثر ارتياحا لنا من الناحية البيئية، أنه ما يكون فيها مواد غير مرغوب فيها. التاريخ حقها من 2500 سنة تم استخدامها على حوض الأمازون لتحسين التربة وجودتها، ومن هذا المنطلق بدأت تنتشر في عمليات عمل استخدامها كتربة زراعية جيدة ومتميزة، تتميز فيها بالرطوبة، المياه، الحفاظ على المياه، استهلاك المياه، أيضا المسامية حقتها ممتازة جدا من ناحية تنفس التربة إلى آخره. في اليوزز موجودة عندنا أكثر من في الزراعة، مثل ما ذكرت قبل شوي، إصلاح التربة والمياه، عمل بعض الأوبورتيونيتي والفرص الموجودة في استزراع في الزراعة بالنسبة للتربة، في الحفاظ على المياه كمصادر والمحافظة على المصادر. سماد عضوي تقليل انبعاثات أكسيد النيتروز وثاني أكسيد الكربون إلى آخره. برضو يعني البي اتش فاليو الموجود في التربة، بالإضافة إلى ذكرناها انكريزا مايكروبيا بوبيوليشن بيزيد بشكل واضح، وهذه يعني الحد اللي فيه مخاوف إذا كان في تأثير على أشياء أخرى بنذكرها بعد شوي. كأعداد عالمية حسب مصدر الانترناشونال انيشيتيف the International Initiative of Biochar and اللي هو البايوشار انيشيتيف في USA، ذكروا انه نورث امريكا 150 ألف طن، هذا بالنسبة ل 2023. أنا أتوقع أنه الأرقام حدثت عند الخبيرة. في اليوروب أند إيشيا مجتمعين 200 ألف مترك طن، وتوتالي 350 ألف طن كإنتاج بمعدل نمو 91%. هذا معدل النمو مرة عالي، واضح وقوي، واضح أنه في توجه عالي جدا. لذلك أنا ما ودي أني أكون أنا النيجاتيف إمباكت في القاعة هذه عن الناس كلها بالبوزيتيف ومتحمسين لهذه الصناعة، بس أنا جيت كإنفايرومنتال ما إحنا نحسب دائما الريسك فاكتور اللي ممكن تحصل على الانفايرومنت حال إذا كان في خلل في عملية إدارة المدخلات اللي تدخل في التصنيع، أو أثناء التصنيع ما اتخذ الإجراءات الوقائية الخاصة بالفلاتر وغيره وغيره. وهذا اللي يخليني بجيها بعد سلايدين تقريبا من الآن. طيب بالنسبة لهذا الجلوبال، السعودية إيش فيها؟ احنا عندنا opportunity عالي جدا، 35 مليون نخلة. النخل بطبيعة الحال بينتج مخلفات بشكل قوي جدا، على الرغم أنه عندنا كلتشر في المنطقة الشرقية بالذات يشتهر فيه، اللي هو عملية حرق مخلفات النخل في المزارع. ريحتها بالذات من الشرقية أو درس الشرقية يشعر بالحنين لهذه الريحة. لها أهداف ولها أسباب لمكافحة أو طرد البعوض، تكون الصقيع في ساعات الفجر الأولى، بيحاول أنه يسوي لها عملية كنترول المزارع بطريقة معينة إلى آخره. هذا الشيء في خوف، في محاذير كثيرة من ناحية خروج الأدخنة، تصاعد الأدخنة، بعض المواد الغير يعني ملوثة للهواء، بالإضافة إلى أنه محاذيرها من ناحية الريسك الخاص بتوسع مدى الحريق إذا كان الحرق غير واعي وغير متخذ أدوات السلامة اللازمة. فهي من الجانبين عندنا مزعجة. المزارع في النهاية إذا أعطيته opportunity حلوة أنه يطلع مبالغ مالية من ويست ماتيريال هو كان بيصرف عليها، بيسوي لها ألف حساب لمعالجتها، هيروح معك مباشرة من الناحية الاقتصادية. الفلوس هي اللي تتكلم يعني في النهاية. الناس يعني هذول ترزقوا الله، فهيتوجهوا مباشرة إلى رفع الكفاءة الاقتصادية الخاصة فيهم. استخدام في السعودية احنا عندنا مؤرق قوي جدا اللي هو موضوع المياه، وكثير من القرارات مثل قرار 66 لإيقاف زراعة الأعلاف وغيره كان انت تتحرك شيء هنا؟ اوكي. كان بهدف الحفاظ على المياه الجوفية الموجودة في المملكة. كون اني انا اوجد تربة في تستطيع الحفاظ على المياه داخلها، او استهلاك المياه يكون اقل في الكونسبشن ريت اللي موجود عندنا، في ظل وجود حرارة عالية في فصول معينة من السنة، يعني معدل التبخير عالي إلى آخره، هذا opportunity قوي جدا لاستخدام البايوشار في تربة المملكة. أنا إلى الآن بوزيتيف، يعني بحاول قدر الإمكان إني أكون بوزيتيف والله. طيب بشكل سريع، وش اللي بيطلع من كل عملية، وش اللي بيدخل بشكل بسيط، وش اللي بيتحول المادة الرطبة أو اللي نسميها الخشب رطب فيه، لأنه وإن كان جاف يعني ناشف صلب، لكن في كمية سوائل بسيطة في الأنسجة الخاصة فيه تحولوا إلى دراي، ثم إلى اللي هو الجاف، ثم إلى شكل التحمير أو يبدأ يأخذ منحنى آخر، وهنا يبدأ التشققات فيه ويتحول بعدها إلى البايو شار أو اللي هو الفحم الحيوي. أثناء عملية تحوله من الأخضر أو الويت الرطب إلى ذا، ففي عملية فقد للسوائل بشكل كبير، فبيطلع لنا بخار ماء. أيضا في عملية التحمير احنا نحتاج كمية من الحرارة بتدخل على عملية التصنيع. إذا أنا عندي مصدر حرارة لابد من معرفة المصدر هذا إيش الملوثات اللي ممكن يطلعها، بالإضافة إلى الأورجانيك بعض الأجسام أو بعض المكونات العضوية اللي بتخرج في هذه الفترة. بيظهر تشققات على الجسم نفس المادة، هذه لابد من دراسة الأجزاء اللي ممكن تتطاير منها من ناحية بيئية، وبعدها يظهر لنا اللي هو الفحم الحيوي. احنا ندرسها بهذه الطريقة، نحاول نشوف ايش المدخلات، ايش بتأثر، من وين مصدر المدخلات، ايش اللي بيخرج، على أساس نشوف تأثيرها على البيئة. يعني ممكن يكون بالنسبة للمتخصصين هذه الرسمة يعني بور مرة، لكن احنا نبسط التفكير حقنا لمدخلات ومخرجات عشان ننظر لها من الناحية البيئية وتعمقنا من الناحية البيئية. بالشكل السابق لاحظت الدكتور لما جت اللي هي البراميل في المزرعة وأسلوب الحرق، يعني أشار بيده كأنه يعني هذه أسلوب قديم يعني أو شيء ما هو منطقي، لأنه في صحيح هذا الأسلوب فيه انبعاثات في الهواء مؤثرة على البيئة، تلوث الهواء وجودة الهواء بتكون يعني بتتأثر بهذه الانبعاثات الموجودة الناتجة عن الحرق. لكن في السيستم الجديد لما تابعنا الخطوات بشكل كمجسم أو كشكل مخطط وين ممكن يكون في انبعاثات هواء، وجدنا أن الموضوع بفلاتر تعاملنا معها كقياسات خاصة بالأبراج التبخير والقياسات الخاصة في حسب لائحة الهواء. وجدنا انه لا، هي اندر كنترول، يعني اذا روعي عمليه المانجمنت والصيانه الدوريه وذا هتكون جدا ممتازه. فقط كان عندنا هاجس انه المخرج النهائي بعد ما يخرج اذا كان ملوث في المدخلات، ففي هذه الحاله سيدخل على التربه كمخرج فحم حيوي موجود في بعض الملوثات الغير مرغوب فيها اللي بثيرها نوعا ما في السلايدات القادمة. هذه العمليات بناخذها بطريقة تحليل أكثر، الخطوات العملية لها من تجفيف، من تحليل حراري، تنشيط وإنتاج الغاز، معالجة. بالمناسبة إنتاج الغاز بيكون أكثر في اللي هو المخلفات الأسمدة والأسمدة بالذات الميثان وغيره. المعالجة المسبقة لتعزيز خصائص الفحم الحيوي، هذه يعني يعتبر تجهيز للفاينل برودكت الموجود. ففي كل مرحلة نبي نشوف وش اللي ممكن يطلع لنا من غازات من أمور. اتضح لنا ما زلنا احنا في المرحلة الأولى التجفيف، احنا قاعدين نفقد سوائل من منتج رطب، فهي بخار موية. في الثانية، في المرحلة الثانية من ناحية اللي هو عملية التحليل الحراري، هيكون عندنا ممكن يطلع عندنا ميثانول، يطلع عندنا حمض ستريك أسيد، يطلع عندنا بعض الغازات الدفيئة الأخرى، وأيضا يطلع عندنا أول أكسيد الكربون وثاني أكسيد الكربون من عملية تكسير السليلوز. في المرحلة الثالثة اللي ذكرتها قبل شوي اللي هي مرحلة المعالجة أو عفوا التنشيط وإنتاج الغاز، بيكون في مركبات متطايرة في هذه الحالة، لأنه بطبيعة الحال إذا كان في عندنا أسمدة أو شيء بدأنا في مرحلة معينة بيبدأ يطلع معنا الميثان بشكل واضح وفج، وذكرها الدكتور عادل قبلي، أو العمليات التجشؤ هذه وهي في بطن الحيوان، فما بالك إذا خرجت. المرحلة الأخيرة لتحسين جودة الفحم الحيوي بيتم استخدام بعض المواد الكيميائية عليه. هنا برضو عندنا مخاوف من أنه يكون في تأثير سلبي على التربة من بعدها، فلذلك وجب أن يكون في quality control test على المنتج النهائي بشكل قوي ومواصفات دقيقة له. من بعدها أنا بركز على نقطة معينة هي الأكثر وجوداً على الفحم الحيوي، يعني ركزوا عليها الأبحاث العلمية اللي هو خاصة بالديوكسين. فعندنا تشير الدراسات إلى وجود الديوكسين والفرمونات في الفحم الحيوي في ظل المعالجة بالحرارة معينة ومدخلات محددة. الخوف من المدخلات، إذا تمت إدارة المدخلات بشكل جيد لضمان أنه ما في أي ملوثات لها تخرج لي هذه المادتين، فتبقى عندنا مشكلة الحرارة اللي بستعرضها في دراسة قادمة. الرينج حقها فاريشن يعني محترم، يعني طلع معي أقل من نانو جرام من المكافئ السمية إلى أبعد من للكيلو جرام الواحد، إلى أعلى من مستوى يبلغ 113، كان أعلى مستوى يبلغ 113 نانو جرام للكيلو جرام الواحد. طبعا الأكثر سمية ظهرت معنا في الحمأة على حسب الدراسات اللي قدمت، الحمأة المنتجة من معالجة مياه الصرف الصحي إلى آخره. فهذه أدت إلى ظهور الديوكسين بشكل قوي جدا وملفت للنظر. بروح بشكل مباشر اللي هو تأثير درجات الحرارة والتغيرات الحرارية، وأتوقع أنه في زميل قبلي ذكر أو عرج على هذا الموضوع، أنه تأثير درجات الحرارة عليها تأثير عالي جدا. لو نلاحظ أنه عندنا أكثر من معالجة حرارية للفود ويست على 400 درجة مئوية، على 600 درجة مئوية، على 300 درجة مئوية، وعلى 500 درجة مئوية. لوحظ أنه الديوكسين يكون عالي في معالجة الفود ويست على درجة 300 درجة مئوية، ويمثل ذلك البيكو جرام حوالي 1.2 بيكو جرام، بينما نسبة الكلورين كونتنت موجودة فيه بحوالي 2.9%. إذن الحرارة هنا تلعب دور قوي جدا في زيادة أو نقص المعالجة الحرارية، أو درجة الحرارة نفسها تلعب دور قوي جدا في زيادة أو نقص مادة الديوكسين والفورون. طيب خلينا نشوف الفحم الحيوي ماذا إذا عدى من هذه الأمور كاملة ووديناه على التربة ذا جودة عالية. في بعض المخاوف اللي ممكن قد تكون هي مجرد مجال للبحث، في أبحاث ذكرتها، ولكن يبغى لها يعني بحث أكثر لمعرفة بالتحديد الرينجات اللي ممكن نشتغل عليها واستخدام الفحم الحيوي. مو رفض استخدامه، وإنما نحاول وضع قوانين ومواصفات دقيقة جدا لتحديد استخدام الفحم الحيوي بطريقة آمنة على البيئة تضمن التنوع البيولوجي واستدامة هذا التنوع. إذا صارت في التربة العالية إذا استخدم على التربة الطينية بالتحديد، راح تقلل من مستوى الماء. بطبيعة الحال التربة الطينية مسامها ضيق شوي، فتحتفظ بالماء تحتها بشكل عالي جدا، فهتقلل من لما بيفتح المسام فهيزود من التبخير، فبطبيعة الحال هيقلل من يعني الووتر هولدينج كاباسيتي. زيادة ملوحة التربة وتغيير مستوى الحموضة، وبالتالي تغير في خصوبتها. إذن أنا بسبب المعالجات اللي تيجي بعدين وذا لابد من وضع مواصفات دقيقة للفحم الحيوي. تأثر بعض الكائنات الحية الموجودة مثل دودة الأرض لها فوائد كبيرة جدا على الأرض، أي نعم أنه الفحم الحيوي بيؤدي بعض الفوائد منها من تحسين مسامية التربة إلى آخره، ولكن لازلنا أنه دودة الأرض لها مهام يعني جيدة ومهمة ما قام بها أو عوضها الفحم الحيوي. هي راح يؤثر عليها بالتحديد في عملية التكاثر وعملية النمو، وهذه كفيلة بالقضاء على دودة الأرض. ولنا مثال دولة من الدول، البرازيل، صار عندهم إفكت على دودة الأرض وبدأوا ينتجوها في مراكز إكثار خاصة فيها ونشرها في الأرض للاستفادة منها. النمو البطيء هيؤدي إلى كائنات أخرى تتغذى عليها، تنمو أسرع منها تتغذى عليها، أو تكاثرها البطيء أو يؤثر على تكاثرها، فبالتالي ازدياد العدد فيها والتزايد فيها حيكون أبطأ بكثير من دورة حياتها، فبالتالي نبدأ نصل إلى مرحلة أنه انعدام وجود هذا الكائن في التربة. بالإضافة إلى مثل ما ذكرت قبل شوي في البكتيريا، بتزيد بعض البكتيريا الموجودة بيتحول أنا وقفت على هذيك معلش. بيتحول، رحت للسلايد اللي بعده وأنا توي ما البكتيريا بعض الفطريات بتتحول إلى بكتيريا، أو بيصير في ريبليسمنت ما بين الفطريات والبكتيريا، وبالتالي ازدياد العدد من البكتيريا هيصير في خلل في التوازن الحيوي الموجود في التربة، فبالتالي عندنا إضعاف في بعض الخصائص المميزة للخصوبة وغيره، خصوبة التربة وغيره. طيب، أنا بتكلم الآن عن القوانين الريجوليشن الخاصة في البيئة، منظومة البيئة في المملكة العربية السعودية. احنا نقسم البيئة المصانع الخاصة بإنتاج الفحم الحيوي إلى على حسب التصنيف إلى 3 فئات، وكل فئة لها متطلبات خاصة فيها. الفئة الأولى هي الإنتاجية حقتها أقل من 500 كيلو جرام في اليوم. هذه الفئة متطلب لها أنه يكون عندها إدارة بيئية، خطة إدارة بيئية كاملة، بمعنى أنت هتسوي عمليات الفحص حقتك، عمليات صيانة الفلاتر إذا كان في عندك الفلاتر حقتك الصيانة الدورية، جدول الصيانة الخاص فيها، الريسك مانجمنت الخاص فيها إلى آخره، يعني تبكل لخطة إدارة بيئية كما ورد في آيزو 14001. فقط هذا المتطلب الموجود. بينما الكاتيجوري الثاني أو المستوى الثاني أو التصنيف الثاني، هذا إنتاجه أقل من 200 طن أو 2 طن يوميا، 2 طن أو أقل منه. فهذا يتطلب أول شيء ترى تصريحين. التصريح الأول خاص بالإنشاء، وهذا التصريح الخاص بالإنشاء هذا Environment Impact Assessment Study، هذا دراسة أثر بيئي على الموقع، في حدود الموقع. لو أنشأت هنا وش راح يصير إفكت على هذه البيئة، أو إيش راح تتأثر البيئة عليها المشروع نفسه بهذا النشاط. وبعدها لما تاخذ تصريح تشغيلي، إذا عندي تصريحين، إنشاء ثم بعد الإنشاء يبدأ التشغيل، وهذا متطلب عليه أنه يكون عندك environmental audit plan اللي هو خاص خطة تدقيق بيئي شاملة العينات وشاملة الأوديت حقك كل كم، جدول الأوديت، أهم برضو الريسك مانجمنت حقك كامل إلى آخره. العنصر الثالث هو مشابه للثاني، ولكن بيتطلب عند التشغيل، طبعا هو قبل لا نبدأ ندخل فيه الكاتيجوري هذا من 2 طن يوميا وفوق. بالنسبة للمتطلبات أيضا إنشائي ثم تشغيلي. الإنشاء مطلوب منه Environmental Impact Assessment Study على المكان. في التشغيل خلاص آخر سلايد. في التشغيل محتاج شغلتين إضافيا، نفس الشغلة اللي هي الانفايرمنت اوديت بلان مثل السابقة، بس يزيد عليه اللي هو سكوب اوف ديترمينيشن. السكوب اوف ديترمينيشن أنا أحتاج إنك تبدأ تقيس لي على حدود المنشأة نفسها وأبعد نقطة ممكن يصل لها الأثر البيئي برا المنشأة، تأثيرك خارج حدود المنشأة التي تعمل على إنتاج الفحم الحيوي. تفاصيلها أكثر لأنها طويلة جدا ولوائح، وفي تابع لوائح الهواء، لوائح جودة الهواء، التربة إلى آخره. ممكن يكون موجودة على موقع المركز الوطني للرقابة على الالتزام البيئي NCEC. ممكن الاستفاضة في معرفتها أو قراءتها للي داخلين على هذا البروجكت أو كبزنس موديل هيسوي. أنا هنا أتوقف، أشكركم جزيل الشكر للاستماع ودعوتي لهذه الورشة.
Thank you, Dr. Bass, for your presentation. Next up, Dr. Afrah Al-Tayyib with her presentation for bioremediation and environmental sustainability.
Assalamu alaikum wa rahmatullahi wa barakatuh. Thank you for the invitation for, sorry. Okay, shukran. Okay. Thank you for the invitation for introducing a part of our research work about the biochar for bioremediation and environmental sustainability. I am Afra Mohammed from Princess Noura bint Abdurrahman University, Faculty of Science, Department of Biology. The presentation outlines, first I will talk about and give overview about our research work, so it is a little bit different from what has been previously discussed. Because here I will present a part of our experiment and the findings regarding the biochar application for bioremediation and environmental sustainability. So it is an overview and how, how biochar improves soil health and mitigating pollution, concept and objective of our research group beside our research approach and our current activities. So as previously discussed and defined the definition of the biochar, so here I will skip this definition because now all of us discuss this point. So I will go immediately to the applications. For example, biochar is introduced to the soil or to the environment for environmental sustainability, to improve the soil health and enhance the soil structure via increasing, for example, water retention and post-nutrient availability, and leading to improved plant growth and reduce a need for chemical fertilizer. Also, we are focusing on the very important application regarding biochar and other materials that we prepared in our lab regarding bioremediation. So we use the biochar for heavy metal removal from the soil, from contaminated soil, since the biochar can absorb and immobilize the heavy metals in contaminated soil and reducing their bioavailability and toxicity. But also we focused on the pollutant absorbance like the antibiotic. Also we tested the ability of the biochar to reduce the antibiotic from contaminated soil. The main objective of our research group here at Princess Noura and in the Health Science Research Center at Princess Noura University, me and my research group, we are preparing fabricated material. So at the beginning, we started by fabricating different material like biochar, carbon dot, but recently, 2 or 3 years ago, we start preparation of a biochar, and we prepare from different biological sources. We use the shell. We have a fruit called Adansone digitata, so we use the shell of this to prepare biochar, but also we use the seeds. The seeds is sometimes the germination rate is not so high, so we use it to produce a biochar. All our work is for research, methodologies, and application. And then when we prepare, so we study the properties of the fabricated material, and then we assess their efficiency or efficacy in mitigating the contamination from a contaminated soil. So I will talk positively about the biochar because we have a very promising results and finding regarding this. So the role of biochar in mitigating the heavy metal and organic pollution degradation, but also recently, because at the beginning when we started, we used the fabricated material, for example, as antimicrobial agent or mitigation of pollution. But recently, one of my colleague, she's a specialist in ecology and seed germination, Dr. Modi Latebi, she asked me to test the possibility of this biochar in enhancing the seed germination. We did, and it was a really very nice comment from her to test, and we found a very positive and promising result regarding seed germination. So we study the antibiotic from different type of soil, and all of us know that the antibiotic in the soil or in the environment have different routes for entry and from the consumption, from the wastewater treatment plants, and all these are the main sources for the antibiotic present in the soil, which affects soil biology, and also it affects the human health via food chain. Again, we have the problem of the heavy metal also contamination in the soil, and also we know the different routes of heavy metal entry to the soil, and also the hazard toxic of heavy metal to human, and which is affect human health negatively. So at the beginning, researchers started to address this problem by using different methods like chemical, physical, and biological method. But recently, adsorption technology has gained much attention because of its high efficiency, simplicity, and low cost, and effective in their cost. That's why we will talk and we will focus now on the biochar because it has high adsorption capacity. So the key properties in using biochar is its porosity and also large surface area, high adsorption capacity beside high cation exchange capacity for nutrient retention. All these properties led the biochar to be a leader as a biogenic agent or safe production for environmental cleanup. So the current activities in our lab to prepare, as I mentioned, we prepare a small amount for the experiment. We prepare the biochar in a muffle furnace at 500 degrees centigrade for 3 hours. We tried different temperature and we find really different characteristic for the biochar, and we choose 500 because 500 provide us with a good characteristic for the biochar, high zeta potential, and good morphology. So we prepare a biochar and we check the properties of the biochar that we prepare from different sources using different instruments like UV and DLS, FTIR scanning, and electronic microscope for determining the properties of the prepared biochar. After we check the characteristic and we find good characteristics that may enhance our objective and lead us to positive finding, we had different type of soils treated with different type of antibiotic and also different type of soil treated with different type of heavy metals. And we consider this as a contaminated soil. Here is antibiotic contaminated soil and heavy metal contaminated soil. After the treatment, we provide the biochar. At the beginning, our focus was only on the nanoparticle carbon dot, but recently, as I mentioned, that's why in this slide you will find different type of materials that fabricated in our lab. After the extraction or the application of the pollutant to the soil, we made the extraction and we combined the soil with the biochar and different material, and then the antibiotic has been checked, used different techniques, LCMS and UV and BLC, and the antibiotic, heavy metal has been detected using ICB. So this is our main focus on our activities. The main findings that we had in our research group, that if we prepare biochar from different sources, we get different characteristics. This is a work of my MSc student under my supervision. So they prepared the biochar with different material and get different characteristics. So one of the students prepared from Adansane digitata fruit shell, and other prepared from Acacia tortalis seeds. As I mentioned, the seeds that we use are not so well, the germination percentage might not be so high, that's why we use it for producing the biochar. And then the produced biochar has been tested. We check the UV and then the FTIR to determine the functional group. And also we use DLS to detect the zeta potential of the prepared material and also the morphology using semantim analysis. These are also another type of biochar from the seed powder of Acacia tortalis seed. So it is different in their morphology, different in their characteristic, and also when they has been used, also they provide different capability in reducing the antibiotic from the antibiotic contaminated soil. So the findings also indicated regarding the removal efficiency of the we used two different types of antibiotic, and we found a very high removal efficiency for the biochar. So when we tested different type of soil, we get removal efficiency, and the removal efficiency differ since the soil are different, and because the soil has been collected from different location, so it has different characteristic, and that's why due to this variation in the characteristics, the removal efficiency is a little bit different, but in all the cases, 40 milligram per ml of antibiotic of biochar provided a percentage of removal. So it is an evidence that maybe if we add the amount of the biochar, if we increase the amount, we may get higher efficiency. And also it was good to mention that different type of antibiotic has been detected by different instruments that differ in their principle in concentration detection, and they showed high trend of observation. So there is a reduction in the removal efficiency, and there is a reduction in the antibiotic from the contaminated soil. Also, when we checked the biochar in a combination with the contaminated soil with the heavy metals, we found that there is a good removal efficiency for the detected heavy metal, but for some reason, maybe the concentration is not so high. In this case, some metals, we didn't find any effect for the addition of biochar to the soil. So our experiments are going on, and we are trying different procedure. We are trying different concentration to know why in one type of soil BB has been removed and another soil is not removed. So it's a research are going under investigations. The interesting point for improvement of seed germination and environmental sustainability, when we checked the biochar, at the beginning, as I mentioned, Dr. Modi told us that we need to treat the seeds with, before the treatment to fasten their growth or to enhance their germination. She treat maybe with hot water, but in our case, we treated with a biochar. So we combined the hot water or normal water with a biochar, and we kept the seeds for some time, maybe 20 minutes, and then it has been germinated in petri dishes, and it was really interesting that these findings, it's really different between control and treated with a biochar. So it gives us a hint that if we use a biochar, it will enhance the seed germination because of nutrient retention and availability, because also a biochar acts as a reservoir for the nutrients that enhance plant growth and early seedling development. So all my findings now are guiding me to a positive response from the biochar in a contaminated soil. So at the beginning, even in the contaminated soil, we can combine the biochar in a contaminated soil, and also it creates a favorable environment for seed germination due to nutrient retention and availability. But also biochar reduce bioavailability and mobility للheavy metal through the adsorption, through the pH alteration, and also through the complexation and precipitation. But also biochar effectively absorb and degrade antibiotic from antibiotic contaminated soil through a hydrophobic interaction. Therefore, the antibiotic can fill the hydrophobic region in biochar carbon structure. So the adsorption mechanism. So mainly all this the efficiency of the biochar might be really related to its adsorption efficiency. So the adsorption mechanism might be through the electrostatic interaction. Since all our findings indicated negative zeta potential for the prepared biochar, so biochar with a negative zeta potential attract positively with a positively charged contaminant like heavy metal and cationic antibiotic. Also, it is very important to mention because FTIR for the biochar detect the groups, functional groups like hydroxyl and carboxyl, which interact effectively with the contaminants through hydrogen bonding. So also it was very important for us to study the characteristic before applying any type of application, and also the porosity and surface area. Higher surface area and microporosity provide more site for adsorption of the pollutant. We had different limitations in our finding and in our study. First of all, the cost of production, because we really apply and produce in a small amount for the experiment only, and also the variability for this biochar effectiveness based on the source used. For example, when we used the shell of the seed of Adansonia digitata fruit, we found a very, the characteristics are very nice. We found the biochar at a nano range, not like when we use the seed. So the variability in the characteristic of the biochar is different according to the livestock used for its production. And our research area, and now we are trying to solve different problems and combining biochar, because in some cases we find no efficiency for the biochar for eliminating some metal from a specific soil. So we are trying to combine biochar with other amendment like compost, like nanomaterial. When I presented the current activities for our lab, I mentioned different nanomaterials and different carbon dots that are used can be studied and can be combined with the biochar to enhance the biochar efficiency in eliminating antibiotic and also eliminating heavy metals from contaminated soil. But also it was very important to mention their role in enhancing of seed germination. So I think here I provide a brief talk about the role of biochar on environmental sustainability for enhancing seed germination, but also for bioremediation and removing of antibiotic and heavy metal from heavy metal contaminated soil. Thank you so much for your kind attention. If you have any question, I'm here.
Thank you so much. We're going to have a general discussion.
Okay.
Thank you, Dr. Afra, for your presentation. Next, Dr. Mohammed Al-Sayadi on review of biochar utilization as sustainable supplement for animal feed.
السلام عليكم ورحمة الله وبركاته. أولا طبعا أنا حضرت السلايد بالإنجليزي، لكن دائما أحب أتكلم بالعربي الحقيقة، لغتنا مليئة بالمترادفات يعني إن شاء الله. فشاهد أنه for non-native Arabic speakers, Dr. Catherine and others, I'll try to come back to any points that you need to ask while in the lectures or during the discussion as they arrange for that. أشكر اللجنة المنظمة الحقيقة على هذا التنسيق وعلى دعوتي لإلقاء هذه المحاضرة، وعلى بركة الله نبدأ. المحاضرة تتناول موضوع جديد عن ما تناوله الأخوة أو المتحدثين، استخدام الفحم الحيوي كمضاف علفي في علائق الحيوانات المختلفة. وطبعا الإخوة الزملاء الذين سبقوني وفروا علي كثير من التعريفات والأشياء اللي يمكن أمر عليها، فربما أدخل على طول على بعض الأمور الهامة. مفهوم الفحم الحلبي هو مفهوم قديم جدا، و يعني من آلاف السنين، ولكن في أكثر من 100 سنة يمكن تقريبا أصبح يستخدم الشاركولز يعني في الريميديز أو في علاج كثير من الأمراض المتعلقة بالجهاز الهضمي. ثم تطور الأمر إلى سنة 2000 يعني كده بدأ الاهتمام بالفحم الحجري كمدخل علفي يضاف للأعلاف. وأيضا يعني في تقدم كثير أيضا في الأبحاث في السنوات الأخيرة، لين وصلنا إلى الوقت الراهن. فلعل هذه الورشة تجسد مفهوم هذا الاهتمام وإضافة البايوتشار كمضاف علفي إلى علائق الحيوانات. الأخوة طبعا اللي ألقوا قبلي يمكن اختصار للوقت يعني عشان كده أنا رحت على طول دايركت إلى الفروق. لابد أن نعرف الديفرنسز، الفروق بين التشاركول والأكتيفيتد تشاركول والبيوتشار. أنا سأتحدث عن البيوتشار كمضاف علفي، لكن لابد وبضدها زي ما يقولوا تتميز الأشياء، لابد من التعريف. التشاركول كما ترون هو طبعا حضر عن طريق البيرنينج أو الإحماء الحراري، وبالتالي تحت بيئة منخفضة في الأكسجين. أما الأكتيفيتد تشارج فهو البايو تشارج يعتبر المادة الأولية لتصنيع الأكتيفيتد تشاركول. وايضا في بعض الخصائص المترتبه على، طبعا في اخوان درجات حراره، ما حبيت اقحم الجدول هذا بدرجات حراره لكل من هذه المنتج، لكن اي يعني اذا اريد المعرفه فيمكن في الدسكشن نتكلم عنه. البرودكشن بروسيس اللي هو برودوس باي كربونايزيشن اور وود، ومثله اللي هو التشاركول، واخيرا من اورجانيك ويست اللي هو يعتمد طبعا البايو تشار اللي احنا نستهدفه في كمضاف علفي، لازم أن يكون من مواد لا تحمل أي ضرر على الحيوان ولا على الإنسان اللي هو يعتبر المستهلك النهائي لهذه اللحوم، سواء كانت يعني لحوم الحيوانات أو الطيور الداجنة أو الأسماك. وايضا السيرفيس اريا، طبعا اللور تشاركول يعتبر لور سيرفيس اريا ليس مسامي، اقل مساميه ومساحته السطحيه قليله. وايضا الاكتيفيتد تشاركول هو عالي السيرفيس وايضا عالي المساميه، وايضا هاي سيرفيس اريا بالنسبه للبايو تشار. كما ذكرت في البداية أنه البايو تشار يهمنا أنه يكون يأتي من مصادر لا تأتي بالضرر على المستهلك النهائي لهذه اللحوم أو اللي هو الإنسان. فبالتالي عندنا عدة مصادر اللي هي الأجريكلتشر، مخلفات الزراعية، وطبعا ما بدخل في تفاصيل اللي هي الكروب ويست، وايضا الليجومينوس اللي هي النباتات اللي هي من العائله البقوليه، باعتبار الاخوان في التربه يرون ان هذا المصدر جيد لانه يعمل نيتروجين فيكسيشن ان ذا سويل، يعني يعمل تثبيت للنيتروجين كغذاء، كمصدر غذاء من التربه وكغذاء للنبات فيما بعد. الفورستي باي برودكتس والانيمال مانيور والفود اندستري باي برودكت وغيرها. طبعا نيوتريشنال فاليو بالنسبه للبايو تشار هو يعمل كعامل مساعد داخل يعني معدة الحيوان. طبعا احنا الآن نميز بين الحيوانات المشترة والحيوانات الوحيدة المعدة، لكن هو دوره انه يعمل ابزوربشنز للعناصر الغذائية ويحتفظ بها في ولا تخرج الى مع الروث بدرجة كبيرة كما في حالة العلاقة الغير مغذاة على اللي هو البايوتشار. ايضا البايوتشار ننظر اليه ايضا طالما انه مصدره مواد عضوية جاية، فهي الالياف ايضا تعتبر من المصادر الموجودة أو من العناصر الغذائية الموجودة في داخل البايوتشار. معادن مهمة أيضا تهمنا بالنسبة سواء كانت ماكرو أو ميكرو، العناصر الصغيرة، الإنرجي، وأيضا وجود الخاصية الأدزوربشن أو الإدمصاص للعناصر السامة والعناصر مثل المعادن الثقيلة وغيرها. طبعا كلها تحمي الحيوان وترفع من الجهاز المناعي للحيوان. الميكانيزم اوف اكشن، كيف يعمل البايوتشار داخل جسم الحيوان؟ لاحظ انه الخاصية كما ذكرت الابزوربشنز هذه توفر مصدر اخر للعناصر الغذائية اللي ذكرتها، وايضا هذا ينتج يعني جهاز مناعي قوي. المعروف ان الحيوان او الانسان اذا ضعف الجهاز المناعي فبالتالي تضعف مقاومة الحيوان، وبالتالي الحيوان المريض لا ينتج. الادزوربشن بروبرتي طبعا نتيجة للخاصية اللي ذكرناها في انه يدمص عليه كثير من العناصر. وخاصية الشاركول يمكن الأخوان يعرفوا هذه الحقيقة، أنه الهيفي ميتال مثلا نيجاتيفلي positively charges while the charge cords may be negatively charged، فبالتالي يحصل attractions ويتم عملية الإدمصاص أو الادزوربشن. ليش احنا أو المختصين في مجال التغذية يحاولوا أنهم يستخدموا أي مضافات علفية بهدف استدامة هذه المصادر وحماية القطاع أيضا. فوجود الخاصية اللي هي أنه يحسن القابلية للهضم ويزيد اللي هو معدل اللي هو الزيادة اليومية في وزن الجسم وأيضا في الكفاءة التحويلية للحيوان. أجريت عدة تجارب على أصناف مختلفة من الحيوانات، سواء كانت الحيوانات المشترة والدواجن اللي هي بشقيها اللاحم والبياض وأيضا الأسماك. لكن طبعا الوقت أنا حاولت إني ألخص الموضوع يعني بالنسبة للحيوانات. ففي حالة الماشية طبعا دكتور سميث في عام 20 وحسب طبيعة المادة لو البايت شورك كول محضر من أي مادة، محضر من أي فيد ستوك، المصادر اللي ذكرتها في أول سلايد. فبالتالي من الود ما بروح لكل السبلمنت ليفل كان 2%، وبتكلم على الدوسج أو السبلمنت ليفل في السلايد الجاي. يعني لمدة 12 أسبوع أدت هذه الدراسة إلى زيادة إنتاج الحليب في الأبقار المغذاة على هذه العلائق المحتوية على البيوتشار. كانت الزيادة حوالي 10% في نسبة أو محصلة الحليب أو إنتاج الحليب، وكذلك 15% في الكفاءة التحويلية لهذه العلائق، ومثل الجنسن وآخر. فانتقل إلى الموضوع الآخر اللي هو الشيب. الشيب يعتبر أيضا من الحيوانات المشترة، ونفس الترند يبدو في لأن الباحثين معظمهم يعني غدوا على الأبقار وغدوا على الأغنام، غدوا حيواناتهم هذه على البيوتشار سواء كان للأبقار أو الأغنام. فهذه النتيجة كانت إنه بإضافة 2% في العليقة من البيوتشار، فبالتالي زاد الويت جين اللي هو الزيادة اليومية للحيوان المسمن أو المربى من الأغنام، وزادت أيضا الكفاءة التحويلية. هذا طبعا كمثال، وإن شاء الله إذا في أي سؤال بعد البولتري. البرويلر نفس الترند، نفس الباحثين، بس الفرق بين الحيوان المشتر والحيوان اللي هو الوحيد المعدة، وكل التأثير الصحي واحد لكن التأثير الغذائي مختلف. وأيضا حسب مصدر الفيد ستوك اللي هو جاي منه البيوتشار. فنلاحظ أنه في حالة الدواجن اللحم 1% of the total diet أضيفت على العلائق المغذاة على البيوتشار مقابل العلائق الغير مغذاة، وكانت مدة التجربة حوالي 6 أسابيع. نفس النتيجة اللي هي زيادة في وزن الجسم وأيضا زيادة في الكفاءة التحويلية. وكذلك الأسماك الليرز زاد معدل البيض وزاد معدل اللي هو الإيج كواليتي اللي هو شل اللي هو قشرة البيضة كانت أسمك بشكل أفضل عندما استخدم اللي هو البيوتشار في العلائق. الفيش كذلك استخدم نفس الترند، ومن الود وجدنا انه السبلمنت كانت هنا ارفع شوي لانها هي مونوغاستريك، تتبع المونوغاستريك الاسماك، فبالتالي كان معدل اضافه 3% في العليقه، وبالتالي لمده 10 أسابيع. وكان زياده ايضا زياده معدلات النمو، زياده في الكفاءه التحويليه، اي 15% انكريز في معدل نمو الأسماك، وفي الكفاءة التحويلية للعلف حوالي 12%. environmental impact، الأخوة تكلموا الحقيقة عن environmental impact، ومنها الكربون sequestration اللي هو عزل هذه الكربون، ذرة الكربون، وهي عندنا في الكرش طبعا تساهم هذه في تأثير على البكتيريا الموجودة داخل الكرش، فبالتالي تمنع يعني إنتاج غاز الميثان اللي هو يعتبر من الغازات اللي تحدث تغير في أو انبعاث الغازات المؤثرة على التغير المناخي. reduction of methane emission كذلك، يعني هو من الغازات ثاني أكسيد الكربون أيضا. في غازات أيضا اللي بنتكلم عنها ليتر. الويست مانجمنت تكلموا عن الأخوان بما فيه كفاية. هنا نجي الايكونوميك كونسيدريشن، هل إضافة البيوتشار في العلائق مجدي اقتصاديا ولا لا؟ طبعا احنا في علائقنا نؤكد على ما يسمى او نعمل فورميليشن او تركيبات مثلا بالليست كوست راشن، يعني العلقه لازم تكون تعطي مردود على الحيوان المغذى عليه هذه العلائق، وايضا الجانب الاقتصادي الكوست. لو كان يعني نحن متأمل الأخ كان اللي قبلي يتكلم على أنه يعني متفائل بأنه يعني يكون نتائج إيجابية من ناحيتين. احنا تهمنا في الإنتاج الحيواني اللي هو النواحي الاقتصادية وتكلفة المنتج، وحتى في الاستخدامات الأخرى، لأن الجانب الاقتصادي مهم جدا. فالايكونوميك كونسيدريشن انه الكوست بنفيت اناليسيس هذه مهمة جدا، انه نقارن بين الفائدة والتكلفة. و ايضا الماركت ديماند، طبعا الان في توجه كبير الحقيقه في السنوات الاخيره نحو استخدام البيوتشار وبقيه الانواع من الفحم الحيوي في اينما وجدت الفائده، يعني ففي تزايد كبير جدا او اهتمام كبير في استخدام الكوست كومباريزن. طبعا احنا عندما نقارن يعني شيء طبيعي نقارن العلائق التقليديه، والمقصود بالعلائق التقليديه هي العلائق اللي معروفه لدى الناس، اللي هي سواء الشعير او البرسيم او الرودس، بعض الفيد انجريدينتس اللي هي مدخلات العلائق الاخرى. فاذا اضفنا لهذه العلائق البيوتشار، فهل التكلفه أكثر أو أقل؟ هنا هو اللي يحكم الأمر هو الجانب الاقتصادي، ويبدو أنه في البدايات ربما التكلفة الناجمة عن تجميع المواد العضوية وأيضا حرقها وإنتاج البيوتشار ربما له تكلفة عالية، لكن إذا إن شاء الله يعني تم إنتاج الفحم الحيوي على مستوى كبير جدا، فبالتالي طبعا عرض وطلب، فبالتالي يكون التكلفة الاقتصادية أقل وتحقق الفائدة من في علائق الحيوانات، في إضافته كمضاف على في علائق الحيوانات. أيضا challenging utilization في قوانين، والأخ الهلالي يتكلم عن القوانين، ويسعدنا أيضا نسمع أنه في قوانين مبكرة الآن بدليل على التفاؤل والتحمس لإنتاج مثل هذا النوع بالنسبة لنا كمضاف علفي. فهو ذكرت القوانين اللي هي المنظمة في السعودية، وذكر الأخوان المحاضرين ذكروا عن EBI اللي هو Environmental Biochar Environmental Biochar International و International and EBFS اللي هو International Biochar Foundation. وأضيف إليها بالنسبة لنا احنا كريجوليتي باديز أو كجهات منظمة للغذاء الأغذية، ومنها الأعلاف يعتبر من الغذاء، منظمة الصحة العالمية، منظمة الأغذية والزراعة، European Commission، إفسا اللي هو European Feed Authority Safety Authority. فهذه كلها قوانين مهمة جدا، بحيث أنه المنتج هذا بيروح للإنسان، ولا بد يكون التأكد من الكواليتي and safety اللي هو النوعية والسلامة أيضا أو سلامة المنتج. وأيضا قاعد تكلموا عليه بعض الأخوان الدوسج ريكومنديشن أشارت معظم الأبحاث إلى أنه الرينج في التجارب اللي شفتونها يعني من 1 إلى 4%. بعض الحيوانات ما تقبلت 4% أو 3%، وبعضها تقبلتها يعني، فهذا عامل مهم جدا. وأيضا نرجع إلى المصدر هو الفيد ستوك، استخدام هذه المواد اللي قد بعضها مناسب بعضها قد لا يناسب لا الحيوان ولا أيضا الكونسيومر بريفرنس اللي هو يعني تقبل الإنسان إذا كان مضاف. الإنسان الحمد لله في السنوات الأخيرة يعني يتقبل أمور كثيرة يعني في هذا المجال، لكن من باب أولى البايوتشار طالما جاء من مواد عضوية فبالتالي يكون يعني أكثر سلاسة في القبول يعني. ريسيرش اند ديفلوبمنت كما ذكرت يعني في السلايد اللي راحت انه فيه اهتمام كبير في الابحاث الحقيقيه ومتزايد، ولعلنا احنا ان شاء الله هنا في المملكه يعني نشارك الاخرين بهدف يعني وجود مضافات علفيه تكون لها طابع الاستدامه. الاستدامه مهمه جدا، يعني لو انتجت اي منتج واما كان لسعره او لعدم وجود مصادره الأساسية اللي يصنع منها فبالتالي لا فائدة من هذا المنتج. وأيضا الفيوتشر دايركشن تكلم عنها الزميل اللي قبلي وكذا في الأنيمال فيد. هنا بالنسبة لنا احنا نحاول ان احنا نواكب الموجود الآن إن شاء الله، وعندنا في الشركة يعني توجه إلى دعم مثل هذه الأبحاث إن شاء الله لتحقيق الاستدامة ولتحقيق أيضا الأمن الغذائي المنشود. في ريكومنديشن في عجالة، يبدو الوقت أدرك ولا لا باقي عند شوي وقت. فيوتشر ريسيرش يعني نحتاج إلى أنه تتواكب الجهود محليا وأيضا عالميا في يعني تبادل المعلومات لمضي بهذا المنتج إلى بر الأمان زي ما يقولوا. Optimization of biochar characteristic اللي هو إنه لابد من التأكد من الخصائص اللي تجعل هذا المنتج مناسب كمضاف علفي، وأيضا بذلك إذا صار تحققت فيه شروط الجودة والسلامة فيكون سهل إضافته في علائق الحيوانات. Health and Safety Monitoring طبعا ذكرت الريجوليتوري باديز أو authorities مهمة جدا أنها تراقب، لأن هذا المنتج سيضاف العلائق وبالتالي قد يحصل إذا كان هناك أي أشياء سلبية في جسم الحيوان وبالتالي تؤثر على الإنسان اللي هو باعتباره المستهلك النهائي. أيضا نشجع أو نحفز اللي هو كل الجهود في هذا الجانب بما يحقق الاستدامة لهذا المنتج أو لغيره من المنتجات يعني. ولا بد من التعاون في مجال التصنيع سواء كان محليا أو عالميا يعني مع الجهات المختصة، وأيضا لا بد من تدريب المهتمين ستيك هولدرز الموجودين في المجال على يعني إذا يقولوا فاقد الشيء لا يعطيه، فبالتالي إذا ما هو نفسه اقتنع أن هذا المنتج كمضاف علفي يمكن الاستفادة منه ما لابد ندربهم ونوعيهم بهذا الجانب. وأخيرا overall summary احنا I work in Arasco company. Arasco is Arabian Agricultural Services company. We are the largest feed millers in the region. We tend to produce 4.5 million of feed annually per year. We are putting, we try to rank ourselves as a helper to achieve the food security الأمن الغذائي in the kingdom. وأيضا لاحظ أنه الاستدامة عامل مهم جدا والأخوة يعني يبدو في جهود كبيرة جدا، سواء كان في قسم التربة البروفيسور عبد الرب الرسول، ترى أستاذي بس أنا صغير، أصغر مني يعني. نعم. وأيضا نحاول إن احنا نقلل الاعتماد على الكونفنشنال سورسز، ونؤكد على استدامة ما يمكن تبنيه كاستدامة من مدخلات الأعلاف. راسكو بادرت منذ بداية إنشائها إلى تبني فكرة الالترناتيف رو ماتيريالز، اللي هي بحيث أنه يكون في مدخلات متنوعة ومضافات علفية متنوعة في هذا الجانب. لا يفوتني أن أشكر الأستاذة منال القصير، هي منسقة الأبحاث والتطوير، ترى ده كل جهدها يعني الحقيقة. أنا كنت مسافر وهي أعطيتها المعلومة وحطتها في الوضع الجميل هذا. إن شاء الله يكون جميل. أشكركم على حسن استماعكم، والسلام عليكم ورحمة الله وبركاته. بالوقت ملتزمين؟
Thank you, Dr. Muhammad, for this enlightenment. Next up, Dr. Khalid Hussein is going to join us from behind the screen on his presentation on eco-char production from poultry litter as a management approach by Al-Mara'i. The mic is yours, Dr. Khalid.
Thank you very much. Thank you. Good afternoon, everyone. I will try to be very short and brief. I think a lot of guys already talk about biochar or ecochar, so I will try to be more, in a helicopter view, but more than happy to answer any questions if that come on the discussion. So my approach was that we need to have a kind of solution for poultry litter management. We come with in discussion that what it could be the best solution for that. So we been in touch with a company in Netherlands called Mavitech, and we build a gasifier, as you can see from the first slide. I'll go through that process first, and then we can talk about the final product. So we build this gasifier. We have a approved construction license and as well operation license by the Ministry of Agriculture, as my predecessor talked about licenses of these premises. So as you can see, I will go further on that. I don't know if that working from, yeah. So as I said, it was one of the solutions we've been looking. We look for other solutions as well for poultry litter management, as composting and other things, but we found it that the fastest solution it could be the gasification and producing ecochar or biochar, as a couple of speakers mentioned it as a biochar. So I'm trying to go back to the plant. So as you can see, we built this plant, very strict biosecurities. The product, I will try to demonstrate it. The product will come from this side. I don't know if you see my, I will try to show it. So this way the product will come, and then it go inside, and I will go inside the factory, and you can see some heat treatments happening, very high heat treatment, and then the final products coming from this main gate. There is washing areas for the vehicles was coming in, and the all strict biosecurity. All the guys who work inside the factory get shower in and shower out before they go to their accommodation. Right, inside the factory we have 2 lines. I just take a brief this week production, just to give a couple of figures. We have 2 lines, as mentioned. One of the lines is doing 197 metric ton, and another line is 193 metric tons. So we're talking about 400 metric tons of raw materials coming to the factory and gasify that. on a daily basis, we can do around 86 metric ton. And then the output is around 50 metric tons of the EcoChar product. This is inside the factory. I tried to pull a better picture, but I just to demonstrate it, I get this from Mavitech, just a simple explanation, and I think you are maybe familiar with that. As I said, if you look to the point one, that's a tipping place, and then the product go inside, and you go to the rotary drum dryer, okay, and then it's going to the cell cone. What is the hot air streams coming in, and I will jump to number 5, and then is going to number 6. Where is the gasifier? It's happening with high temperature. The temperature could go to from 860. I just check, roughly before the presentation to 900 Celsius. As I said, same line. They are both same line, similar. So we're looking for expansion. We want another 4 line to come in. So the outcome, it's very good. It's helping us to manage our poultry litter and comply with the authorities. So this is just schematic, exactly how the product going in. Maybe you are familiar with that already. The heat treatment is going in the product, and then we have the final product. It's what we call it a biochar. We call it an EcoChar, all right? And as my predecessor speakers mentioned, that is a good soil could be used as fertilizer. I will not go into more details on that. And the contents already, my predecessors and previous speakers already mentioned that. It's a good fertilizer if you've been used rightly. They need some adding because as we know, the pH level, it could be affected the soil. So we did some work on that. So I will not go, and there are some very good minerals, on the EcoChar or the biochar. Absorbent, very high absorbent level. It's a dry, it's free from pathogens. There is no pathogens. One good thing I hear from Dr. Falah, what she mentioning about antibiotic. The beauty of Marai, that we don't use any antibiotic in our production. So it's a zero, antibiotic. We're not talking about withdrawal period. We're not talking that our production, we don't use any antibiotics. So that's giving us the raw material. What we're using is free of antibiotic, free of pathogens, then coming out of the product. And that's a product is really interested with. A lot of customers are interested on. They test it. We did some work with, without naming the university, so did some trials with the final product and did some adding, and we see under certain areas they use it. There is a return in investment, and there is a really helping the soil for agriculture. And we're looking for other opportunities as well, what it could be more, how we can manage the litter in a different way. Running cost is a bit high here, right? So it's required a lot of energy, as you can see, but it's a very, very efficient operation, to be honest. For this reason, I want to be very short because I'm heading for a budget meeting soon. More than happy to answer any question, please feel free. That's all from my side.
Thank you, Dr. Khalid, for your dedication and for joining us from far away from here. I hope you're listening to us. So
yeah,
for now,
I'm here with us. Yeah.
Yeah, great. Thank you so much. So for now, we're going to have a break from 10 to 15 minutes to do the Dhuhr prayer, inshallah. Thank you so much. Ladies and gentlemen, our esteemed guest, we're going to start within 2 minutes, inshallah. Hey. So, change of plans, we're going to start now with Dr. Nasser Khan on biochar for enhancing quality of poor contaminated soils and improving plant growth. Dr. Nasser? Yeah, the mic is yours.
Hello. Okay, thank you. Assalamu alaikum. Good morning. The title of my presentation is Enhancing Quality of Poor Contaminated Soils and Improving Plant Growth Therein using Biochar Compost and Biochar Amended Compost. Okay, before I present the main research study, I would like to give you a little background as a context for my research. It was a past study and it was published. So it is about effects of biochar and compost on turf grass root growth in sandy soils. The experiment, you can see the experiment here. It was established on a very poor, infertile soil called Jendakot sand. The turf grass was wintergreen, Cynodon dactylon. We dug holes to insert the treatments. We added biochar at the rate of 25%, 50%, 100%, and also 50% plus commercial fertilizer, which are just NPK kind of things. And also separately, we added compost to it. The rightmost picture shows how we sampled and where we sampled. The findings for the biochar amendment was like the available water in the pure biochar was 6.1 times than the Jendakot soil. It increased the pH. It improved soil's nutrient retention. It increased root weight. It increased root length. For the compost amendment, the findings were it also increased pH. It increased root weight and it increased root count density. This is a picture shows how happy the plant roots were in the 100% biochar core. Now I will head into the main presentation, the biochar amended compost study. Biochar is really not a substitute of compost or a fertilizer. Also, we need very high rate application, like 23 tons per hectare. The price is very high, $200 to $2,000. These are in Australian dollars, probably. And the biochar is available in a limited way or limited amount. It's not traditional, it's not common to find biochar everywhere. On the other hand, compost is very familiar to the farmers for thousands and thousands of years. Therefore, if we mix the biochar in the compost, like say 10% biochar in the compost, which is not high, much high, 10% or even 3%. And if we add that biochar compost every year, in that way, the farmer will not feel the pain of the cost. So if they apply a low biochar percentage compost for 5 years, probably after 5 years or 6 years, the critical amount of biochar that is required to make significant difference in the quality of soil, probably we will reach there in 5 to 6 years. And after that, probably we can stop adding biochar and keep adding compost. The biochar will stay there for 10 years, 100 years, or even maybe 1,000 years, depending on the type of biochar. Because the cost spreads over the years, over many years, the first farmer will not feel the pain of the cost. So about the biochar compost, combined advantages for soil quality. The biochar has stable carbon. On the other hand, compost has labile carbon. So the labile carbon means something that the microorganisms can use. On the other hand, stable carbon, which could be aromatic, is difficult for the microbes to break down and use the carbon from it. Both the biochar and compost can have nutrients, and a biochar compost or biochar amended compost can improve the soil quality, remediate soil toxicity, increase crop yield, mitigate climate change. Recently, I published a review complementing compost with biochar for agriculture, soil remediation, and climate mitigation. A book chapter in a very good journal. If you need a copy, please send me an email. For this experiment, it was conducted in 5 stages. In stage 1, I composted the biochar with sawdust and chicken manure. In the stage 2, I incubated the biochar with chicken litter compost. The chicken litter compost came from a commercial producer, so it was ready-made compost. But in the stage 1, I prepared the compost myself in the greenhouse. Over 133 days. Incubation period was also 133 days. In the stage 3, I spiked a very infertile sandy soil, and it was virgin soil. That means it was never, there was no agriculture done on it. So I spiked them with cadmium, copper, and zinc. And then I mixed the co-composted biochar amended, the biochar compost that was done via composting trial, and the biochar compost that was done through incubation trial. I added them and also added 3 biochars and 2 composts to the spiked soil. And then I ran a rhizotron trial. The objective of that rhizotron trial was to find the mobility and phytoavailability of cadmium, copper, and zinc in rhizosphere soil, and also study the biomass and plant nutrition. So these were the 3 biochars. Macadamia nutshell is labeled as BCMS. MS for macadamia nutshell. Hardwood shaving, BCWS. Chicken litter biochar, BCCL. The chicken manure was alkaline, sawdust was acidic, BCMS was alkaline, BCWS was acidic, BCCl was little alkaline. So there was quite a diverse property of the biochars. This was the composting setup where I composted the biochar with the sawdust and chicken manure in 153 liter plastic container, which is a spherical, and it was easy to roll on the floor for aeration. I put about 125 liter of material in it. And the composting period was 133 days. It was conducted in the greenhouse. This was the incubation setup. Again, the same 3 biochars. The incubation pile was 4 kg. Plastic pails were 20 liter size. The incubation period was 133 days. The biochar here was added at the rate of 10% in the composting setup. In the incubation, the biochar was added at the rate of 20%. These are some ACMs of macadamia nutshell biochar at 500 micron, 100 micron, and 10 micron. These are also ACMs of compost. The left one, there are some bacteria. At the right one, there are some fungi. Below, there is a ACM on the left below, composted biochar, and you can see bacteria. And there are bacteria on the bottom right ACM as well. So what I want to say is, after the composting, the environment, due to the environment, composting environment, the bacteria and fungi actually enters the biochar pores or biochar or go into the surface of the biochar. And that is important from the point of view that, okay, if we add this biochar compost to soil, that means we are not only adding nutrients, carbon and nitrogen, but also we are adding microbes like bacteria and fungi, which are very important for soil quality, especially in the sandy soils, which has usually low microbes because of low quantity of nutrients and also low moisture. This is the rhizosphere experiment setup and sampling methods. The rhizotron was made of perspex. There were 2 chambers. On the right side, it was 200 millimeter length. On the left chamber was 100 millimeter length. The width inside was about 6 centimeter. 6 millimeter. The right chamber and the left chamber were connected by a nylon mesh of 30 micron. On the right side, there were the biochar amended or compost amended or biochar compost amended soil, which was also toxic soil. On the left chamber, there was just the toxic soil. The idea was, if I irrigate the right chamber, the water will also pass to the left chamber, and with that it may carry nutrients and metals. What I didn't say is how much cadmium, copper, and zinc I added to spike the sandy soil. The cadmium, copper, and zinc was added at the rate of 2.5, 97.5, and 188 milligram per kg. And that spiked soil was incubated, after which I added the organic matters. The rate of organic matter that I added was calculated to raise organic carbon of the soil to 4%. There was probably less than 1% carbon. I can't remember exactly. Sorry about that. 1 to 2% of carbon was present in the virgin soil. I wanted to raise the organic carbon to 4% for every treatment, for biochar, for compost, and also for biochar compost. The plant I used was triticale, which is actually a hybrid of rye and wheat. I selected that because the pH of soil was very low. Like, sorry, it's not there. It will be somewhere. It's around 4 point something. Wheat will not grow well in acidic soil, so I selected triticale. There were 10 seeds sown on each rhizotron, and the growing period was 28 days. This was the rhizosphere experiment in the greenhouse. Probably Dr. Abdullah, who is probably also a participant today as in the audience, probably he saw this experiment I was doing. The results. Before I go into the results, just let me familiarize you with the treatment labels. Nil means there is no organic amendments, like no biochar, no compost, or biochar compost. So nil is the control, that is a toxic sandy soil. BCMS, biochar made from macadamia nutshell. BCWS, biochar made from hard wood shaving. BCCL, biochar made from chicken litter. Co-compost is the compost that I made in that black sphere, but there was no biochar in it. Co-compost MS had biochar at the rate of 10%. Co-compost WS had wood shaving biochar. Co-compost CL had chicken litter biochar. In compost is incubated compost that was just plainly chicken litter compost I collected from a commercial company and incubated, just left in the bin for 133 days. In compost MS, I incubated macadamia nutshell biochar at the rate of 20% into this chicken litter compost, and so on. Shoot and root weight of triticale. Shoot weight increased only in BCCL and in compost WS treatments, whereas it decreased in compost. That means there was some toxic effect in the in compost amended soil. What it could be, probably it was the DOC and copper. The in compost had high DOC, high content of DOC and copper, free copper. And the copper and the DOC actually forms a soluble complex, and that is toxic. That's why in compost soil had low amount of shoot weight. Shoot weight in all three biochar amended in compost treatments were higher than in compost. I already explained how the DOC and copper works and becomes toxic. Slightly higher weight of roots in the co-compost MS and co-compost WS. When I say slightly, that means it is not significantly high, just high, but it's still interesting. Roots were drastically affected by the in-compost amendment, but the addition of biochar in compost reduced the latter's toxic effect. Okay, so I was trying to say that in compost provided lots of DOC and free copper. The copper was already there because I added the copper in it, 100 and okay. I added the copper. $88 milligram per kg. Because we added biochar in compost, what biochar did is biochar absorbed DOC, and also biochar absorbs copper. That's why the biochar amended in compost reduced the toxic effect of copper and DOC. Carbon and nitrogen in rhizosoil. Well, the biochar itself provides recalcitrant carbon. The compost also provides labile carbon. And we can see that the carbon is high. Even after 32 days, they were not used up by the microbes. The carbon is high because of the carbon provided by biochar and compost. The carbon I forgot actually. Now you can see the carbon in the soil was 2.25. Nitrogen in BCCL, in compost, and in compost CL treatments were higher. It was obvious because chicken litter comes with high amount of nitrogen. So the biochar made from chicken litter still was carrying the nitrogen at high level. The in compost, of course, it was a chicken litter compost, hence it had high amount of nitrogen, and also the in compost CL because the compost had its nitrogen and the BCCL also provided nitrogen. Right. DOC in rhizosoil. Yeah, I was talking about DOC. The DOC in the soil was very low. DOC in the biochars were also very low. Therefore, the DOC in the biochar amended compost.
Dr. Nasser?
Yes?
Excuse me, sorry for interruption, but we are out of time.
Oh, okay.
Can you wrap it up, please?
Yeah, okay, please.
Thank you so much.
Right. So I will do it very quickly. CEC was increased by the biochar, as you can see here. The cadmium, copper, and zinc desorption from rhizosoils, high desorption of cadmium and zinc in control rhizosoil and BCWS treatments. the lower desorption of cadmium and zinc from the treatments other than the control and BCWS. I will summarize them in the conclusion in a simple term. Nitrogen uptake by triticale shoot. That uptake of nitrogen by triticale shoot in BCCL and biochar amended in compost treatments increased significantly. Cadmium, copper, and zinc uptake by triticale shoot. Uptake of cadmium by shoot was lower in BCCL, co-compost, and co-compost WS. There was no significant relationship between uptake of cadmium and desorption from soils. Sorry, the time was over, so I will just conclude it as general conclusions. See, DOC and copper. Biochar solves the DOC and copper that I already said. Hence, the toxic effect of DOC and free copper were reduced in biochar amended incubated composts treatments. pH. Biochar and compost can decrease or increase soil pH and hence influence mobility of metals. So low pH biochar lowered the soil pH because the pH was under 4.5 and hence increased the mobility of cadmium and zinc. Therefore, we see high uptake of cadmium and zinc in such soils. High pH biochar, BCCL, increased the soil pH, which were 5.87 or even higher, and hence decreased mobility of cadmium and zinc. Therefore, we see low uptake of cadmium and zinc and in such soils because there are not much cadmium and zinc in the soil. pH and CEC joint influence. There can be joint influence. Soil with high CEC can bind more contents of metals. That means the metals will be less available. So in case of toxic, a soil with toxic amount of metals, if we add high CEC biochar, that will actually bind the metals and allow the plants to grow. Nutrient load, biochar and compost can supply nutrients like nitrogen, thereby increasing plant biomass. Nitrogen supply by biochar like BCCL and in compost increased uptake of nitrogen by shoots. Thank you very much. If there is any question, I'm happy to answer.
Thank you, Dr. Nasser, for your informative presentation. We are actually going to have a general discussion session later, inshallah.
Okay.
Okay. So last but not least, with Engineer Muqbil Al-Khalaf on his presentation about success stories about Saudi biochar producers.
السلام عليكم، مساء الخير جميعا. We are a small factory in Qasim. We recycle waste from date palms and poultry farms, plus wooden pallets from logistics and warehouses, and figs and usually any wooden-based material from coming out from farms. The problems we have in the raw material is that the date palm is not densed, so a pickup like this, which is a 6-ton pickup, can carry only 500 kg. So this is a cost need to be solved, and we have in the future right solution for it, I hope. We also use as raw material wooden pallets that are broken, cannot be used again. So we have shredders with magnetic that will take the nails. For the cost difference between date palms and the wooden pallets is dense, so it costs us less than using date palms. We make 2 types of biochar, one from wooden based and the other is from chicken manure, pelleted chicken manure. We buy it from Al-Wataniya fertilizer company. And our location actually is only about 5 kilometers from the chicken manure farms. And we are very near to Sheikh Al-Rajhi farm, which is the largest in the world, about 250 date trees in one place. But still the distance is not far, but the collecting part, loading on the truck, then unloading, this is cost. So we are planning in the future to do the shredding in the farms. This is a short video we make 2 weeks ago in the inauguration event for the biochar product at Sako Stores, who's retailing our product. And we are using this reactor. We get the syngas, the non-condensable parts, which are usually flammable, is the fuel for the reactor. And the condensable parts is the wood vinegar. We get it after distillation of the oil. This is the syngas, which is the burning. In the case the feed material is chicken manure, we get liquid fertilizer from the chicken manure, and we use it to inoculate or charge the dry biochar. The liquid part of the pyrolysis depends on the feed material. So if we are using wooden-based material, we get wood vinegar. If we are using chicken manure or cow manure, we get liquid fertilizer. The challenges, problems we had with the reactor when it arrived to the site was in the mid of Corona in China, and supposed to two persons to come for installation and commissioning, but they could not come. They could not travel because of the ban. Their government was the last country to open. So we did the installation and training through WeChat. And we had hard time with the Chinese understanding, even they speak English. But it took us about 6 months. Then we discovered that the reactor was made for pelleted material. Our material is wood shavings or loose material. So in the beginning, when we are operating, we are getting only 15% instead of 35 or 32. So the plates, the guide plates here, were welded 90 degrees angle. So we had to remove all the guide plates and re-weld them again with inclination angle tilted, so the material will travel when the reactor is rotating. So we had to dismantle, take the 3 parts, the furnace, and we remove the guide plates. Then we weld it again. This took about 2.5 months. Manufacturing mistake. After that, we get yield about 35%, so which is satisfactory for us. And now our product just recently, 2 months ago, it is in the one of the largest retailer stores in Saudi, Saku. They have about 31 branches in Saudi. And we do small packaging for the houses, for using for home gardens. And we do larger packaging for the farms and government contractors. We try not to sell the biochar raw because our production is not too much. We try to sell it with added value. We put bitmos. One product is with bitmos for the indoor plants. One product is with compost. And we have biochar biology, which is biochar charged with the liquid chicken manure we are getting when when the feed material is chicken manure. We get the liquid part, and after distilling it, we soak the biochar in diluted, that liquid we diluted, so it will get all the nutrients. And also we do a mix of biochar plus bitmos plus red sand, and we mix that so we have a soil for outdoor plants. Thank you for coming, and just one more, our future plan, my son and partner, he will talk about it.
Assalamu alaikum warahmatullah. Good afternoon, everyone. I hope to be brief. For our future plans, we have been in contact with Saudi green initiatives, including Green Riyadh, the Sports Boulevard, and we have sent them samples, and we're awaiting their response and results. Based on the response, we hope to expand our production. And since we have graduated from the Ministry of Industry's accelerator, the first of its kind this year, Numu, I believe its name. Since we graduated from that, we can secure financing from SIDF very easily, and we're very optimistic and hopeful. Thank you all for listening, and if you have any questions, we'd be happy to answer them. Thank you.
Thank you, Engineer Muqbil, for your presentation. Ladies and gentlemen, esteemed guests, as we come to the end of this fruitful workshop, I would like to extend my heartfelt gratitude to all of our distinguished speakers and guests for their insightful presentations, to all of you as well as our watchers from our broadcast channels. Your contribution have made this workshop a resounding success, and I am confident that the knowledge shared today will drive forward our collective efforts in sustainable agriculture. For now, we're going to have honoring ceremony with Dr. Khalid Al-Ruhaili to our esteemed speakers. Sorry, there was a misunderstanding. We're going to have a general discussion for now for 15 to 20 minutes, inshallah. So if anyone would like to ask something to any of the speakers, please raise your hand. Just mic. Well, mic.
Assalamu alaikum. Good afternoon. Thank you very much to the organizers and to all the speakers. I think it was truly an insightful session. My question pertains to perhaps maybe it's more related to the NCEC and the national regulations, and maybe if there are also personnel from MIWA, is on the standards or the specs for the product that would qualify for the certification. What would qualify as a true biochar that can be labeled into whatever the right commercial labeling for it, and hence open up the market for it. My second question is with regards also on the market of it. I'm from CIRC, the Saudi Investment Recycling Company. Sorry, I didn't introduce myself. I'm Sultan Al-Saif, overseeing the technology and innovation. The second question in terms of the indexing and if there is any sort of, and this is perhaps maybe from the international stand, maybe Catherine, if you can address this, are there any typical index pricing for the products, or is this based on each market and just left to the free economics and the market demands? Thank you.
I think this question is directed to...
Do you want me to answer now?
Yeah, if you allow me, I will just answer the first question regarding the standards. I know MIWA, Department of Agriculture, now they are working to develop standard for biochar for Saudi agriculture. They just, yeah. Very standard. Okay, Dr. Basir.
Okay. First of all, if we're talking about what I mentioned in my presentation is environment regulation. So regarding to NCEC is the regulation for the facilities that producing or processing the biochar. Regarding to the biochar itself and its use and safety use in the environmental, it will be also the kind of operational that the final product, because it will be touchable directly with the soil, so it's need a certificate as an operation that you already the processing and even the outcome of the final outcome, our final product, is matched with the environmental requirement. The quality is something else. I'm talking about you producing safety product for environment. The quality, the character of the quality, the product quality itself. So it will be matched with the market first of all, because the regulation usually be the minimum required for the safety, for the environment, or for the planet, or for whatever. But to increasing the quality and reducing it's regarding to the market. And then you need to have in your company a research and development, and they usually matching with the questionnaire and surveillance with the market, with the people who use this kind of product, and you're trying your most powerful to match the marketing required. Thank you.
Okay, there was one raising his hand there. Yes. Yeah, second question. Yes, sir.
And as well, there, up until earlier this year, was the International Biochar Initiative standard, and that tested for two things. One was safety from heavy metals and all of that sort of thing, and then the other was durability. So that the proxy for that is the carbon to hydrogen ratio, I think it is. So it had to be 0.7 or below to qualify, and they're still using that standard if you want to get carbon credits for it. But it always defers to the national standard for, you know, soils and their toxin levels. So as far as pricing and markets, it's all over the map, I hate to say. In large part, though, it's due to what is the market you're looking at. So if you're looking at agriculture, it's pretty low because farmers can't afford it. If you're looking at water filtration, it can be much higher. Again, you may not qualify for carbon credits for that. The building materials, it's also quite low for things like concrete and cement. And in the US, it's maybe $200 a ton that they can afford. In Europe, where the regulatory framework is different, it's probably $1,000 a ton. So you really, that's what that map is for, to look at, you know, what are you displacing as a material? What does that material cost? Yeah. So.
Thank you so much.
This one to Dr. Kathleen. It's about the forecasted growth rate for in volume prospective for biochar and also prices forecast. The second question is to Dr. Oda. It's about carbon capturing. Are you talking about the process itself or improving the soil capability to capture more CO2? That's two different subjects, so I would like some clarity on that, please.
Rate that I had quoted is about 20 to 30%. I actually think it could be far higher than that, and it probably is, except what they're selling, the black stuff that comes out, is into the energy market. But there are so many charcoal producers that want to make the switch and increase the heat that they're using to produce a high quality biochar instead of charcoal. So I think for the next 5 years, we're going to see some phenomenal growth if we can figure out the markets. I was just talking about the price of the biochar. If your question was about the price for the carbon credits, right now it's somewhere for high industrial scale production about $150 to $175 per ton of carbon dioxide equivalent, which you multiply by 2 or 3, depending on your carbon efficiency in your process, to get the per dry ton of biochar. So, you know, that can add up to $500 or more just per ton of biochar for the carbon credits. And that's what's enabling people to give it away in some cases where they're getting paid for the renewable energy, and they're getting renewable energy credits, and they're selling the bio oil for carbon sequestration as well. So there's so many different combinations of revenue streams that it's really hard to say, you know, what you should sell the biochar for until you know what that is. But the lower scale credits, when you're in, you know, artisan or low tech production of biochar, those credits are selling probably around 80 to 100. So I hope that answers your question.
Any other questions? In the back? دكتور.
عليكم. سلطان العيد، مدير عام المركز الوطني للزراعة العضوية. طبعا أنا على نهج الدكتور محمد الصيادي اللي هو اللغة العربية، وما شاء الله يعني زاهر بالمفردات. طبعا أشكر استدام على هذه الورشة التي تتناول منتج مهم في الاستدامة البيئية. طبعا الفحم الحيوي له دور كبير في تحسين خواص التربة مثل ما هو معروف، وترشيد مياه الري والحد من انبعاث الكربون، وكذلك هو مخزن للعناصر الغذائية والحد من التصحر وحماية النبات من الممرضات التربة. لكن يعني أنا سؤالي للدكتور باسل بخصوص ما هي الحدود القصوى والمسموحة لإضافات البيوشار للتربة أو النبات، خاصة أنه منطقتنا يعني المملكة أو المنطقة العربية تعتبر تربتها ترب قلوية، ممكن الإضافة الزايدة يسبب مخلبية أو يعني دمصاص للعناصر الغذائية. وشكرا لكم.
طيب بس المعذرة قبل الإجابة عن هذا السؤال، كان في سؤال ثاني عند الأخ الدكتور ناصر عودة. مو موجود؟ طيب تفضل.
عندي. طيب أنا أتوقع السؤال هذا أنا من ناحية بيئية كإفكت على التربة ويغير من خصائصها. في عندنا لائحة خاصة بالتربة فيها المواصفات أنا ما أدري مين مصدر السؤال، كذا ولا كذا، أنا موجه ما أدري وين. طيب فيها خصائص محددة إنه ما تزيد بعض العناصر، فيها تفاصيل للعناصر اللي ما تكون زيادة بعد استخدام وقبل. طبعا الفحوصات في قبل استخدام الإضافة وبعد استخدام الإضافة. هذه الرينجات هدفها عدم تغيير خصائص التربة. أما فيما يخص موضوع الإنتاجية وتغير الخصائص، بطبيعة الحال أنا ذكرت بشكل سريع أنه في تأثير على خصوبة التربة في حالة إذا كانت في تربة قلوية، بيزيد من التغيير في البي اتش الخاص فيها وملوحتها إلى آخره، فتضطر أنك تدخل في مرحلة تصحيح، ما نسميه إحنا في البيئة التصحيح البيئي، مواقع متدهورة أو مواقع متدهورة بيئيا. لكن أنت الآن في أراضي مستصلحة وبتحاول أنك تساعد، ما بتوصل لمرحلة أنه التدهور البيئي. إحنا بتوصل لمرحلة أنه بدأ إفكت صاير على الزراعة، وهذا غالبا أفضل مني، وإن كان عندي معلومة أو شيء يفضل الموجودين لا يفتوى مالك في المدينة، الناس اللي مختصين في موضوع استخدامها في الزراعة يعني، أو تكلموا عن هذا الموضوع بالتحديد. أما بالنسبة لما يخص البيئة، هذا أتوقع أنه موجود التفاصيل في الموقع، ما تحضرني أرقام الصراحة الآن.
يعطيك العافية. أنا I will refer الكويشن للدكتور أستاذنا بروفيسور عبد الرب رسول. شكرا يعني you remind me this question. من الستاديز اللي سويتوها دكتور سعودي biochar initiative recommendation دائما to acidify the biochar because the biochar is high pH. So is there any proof about the effect of biochar or the pH of biochar in soil? Because I believe the pH, it will not affect, this is my feeling, I didn't do any research, but just from my background, I believe that, or I assume the pH of biochar, it will not affect the functionality of biochar. But maybe Catherine, if she has any, or Doctor, did you do any trial about different biochar pH level? شكرا.
شكرا جزيلا. effect of biochar يعني it's من الجماعة اللي بيشتغلوا في السويل كيمستري. احنا we have a calcareous soils with high pH. You shouldn't add a pH يعني with a high pH, so you will have a negative effect on the uptake of the other elements like zinc وغيرها. This is their concern يعني. أعتقد if you correct
For fertilizer, yes, fertilizer should be acidic.
yeah, but you make it, you might.
We apply the biochar. Is the biochar going to increase the pH of the soil? Maybe this is the question.
This is I'm not sure. Definitely, it's you add a pH of 11. I mean 12, with a pH of 8, you're going to increase it. But I don't have a. I think don't see here that people from soil chemistry, but there fears that you increase the pH definitely by if you add a materials or a compounds with pH 12 or 11 to a soils of pH 8 or that, you're going to increase it. This is it goes without saying. But I will go back to the questions raised earlier about the standardization. I think this is one of the things that we have to deal with it before also. We have to put, what do you call it, quality or standardization. We have to deal which kind of products that we want to add to our soils. And this is part of the standardization before you go and give an okay to the manufacturer to sell or put the biochar in the market. Thank you again.
دكتور عادل.
Thank you so much. حقيقة يعني let's speak in English for Kathleen. Thank you so much for all the speakers, for all the participants. Really enjoyed high-profile workshop, very insightful presentation from all presenters. Again, I'm going to speak about optimization of biochar. As I said, it is a function with multivariables. If feedstock is different, the whole process will differ. If the pyrolysis conditions is different, the whole process will be altered. If the end products, even the end products will be different according to the first and second variables, etc. In that sense, I think we need some kind of optimization to specify specific feedstock for agricultural purposes through different, what I can say, pyrolysis conditions and etc. If we go through that, I think we can harness, this is the word I use, we can harness the best of biochar. One size did not fit all. We need to be very flexible. We need to be very specific regarding the uses. We have here, for example, I have 4 items biochar, one from Austria, Vienna, one from USA, one from Switzerland, one from Finland, and lots from USA, and one from India, and one from Saudi Arabia. If we take these samples to a laboratory, we will have totally different lab test report. This is the whole story. It is very versatile, very different to have optimized standard. But we can have optimized standard for agriculture. We are badly in need of this. Another thing, going through waste management and sewage sludge treatment, we can harness the environmental dimensions, the environmental positive impact of this process. Even the end product will be less standardized, and still we can have much of environmental benefits. I think it is time to scale up biochar industry in Saudi Arabia. I call again for more coordination, more harmonization. We are very open, very flexible. We need to be part of your colleagues, Saudi Biochar Research Group. We hear about this Biochar Research Group. It is time to engage others. We are very flexible to engage even our partners from industry, from whatever. Even our colleague from Silk is highly enthusiastic to see this biochar to be up and running as a smart product. Thank you so much for all the people, and I would like to thank again Kasim Draber for being with us. Thank you so much.
Any more questions?
Yes, for Dr. Catherine. To know what's the minimum quantity to get this carbon credit? You said it is $500, and what's the minimum quantity a factory must produce so it will get carbon credits? And just one more question. If a factory gets carbon credit, it will start calculating from the date of getting the certificate, or also counting the past recycled biomass?
That's unlikely, I'm sorry to say. There's a process of evaluating whether your system is truly carbon negative. There are situations that I've seen plants and I just can't figure out that they actually are saving carbon. But as far as the minimum production quantity, it depends on which methodology you go with. I have heard, and there are exceptions to this, that Puro likes to look at plants that are making at least 1,000 tons per year. Under carbon standards, it's cost effective if you're only producing 100 tons per year. But I will tell you that there's a whole process to getting onto these systems and sampling the biochar, not just in the very beginning, but continually. So there's some added work there. And then the process to find buyers for your credits is very competitive right now, which is why one of the reasons why I suggested that maybe we can find some local buyers. As to how many credits are out there, nobody really knows. It's a lot. When I wish I had tallied this up. When I looked at 24 biochar proposals for buyers, it was 100,000 or 200,000, and that was 6 or 8 months ago, and it just keeps getting bigger. But I think one of the trends I didn't have time to talk about is something called insetting. I don't know if that's common knowledge here, but it's looking at the food industry that is being pressured to reduce their emissions, particularly on the farms. Companies like Nestle and Unilever and Pepsi, they are now buying credits, and with the credits, they're buying the biochar too, to enable the farmers to not only sequester the carbon in the biochar, but reduce the fertilizer impact on their greenhouse gas emissions. So I think that trend is going to just start taking off in the same way that carbon credits has over the last 5 years.
Thank you so much. This is all the time we have for the general discussion. Thank you so much for your informative and engaging discussion. For now, or as they say, great things comes last. The closing speech from Dr. Khalid Ruhaili.
السلام عليكم ورحمة الله وبركاته. يعني في نهاية هذه الورشة الماتعة لا يسعني إلا أن أشكر جميع الحضور، المحاضرين والسبيكرز والحضور على إثرائهم ورشة هذا العمل. اسمحوا لي أن أشكر زملائي أيضا حمود من إدارة الشراكات، الأستاذ حمود النغيمشي على حسن التنظيم، وأيضا الشكر الكبير إلى أستاذنا الدكتور عادل على إثراء هذه الورشة، يعني اختيار المواضيع واختيار المحاور، فكانت يعني اختيارات موفقة من الابليكيشن إلى التصنيع إلى الماركت. Special thanks to Catherine for joining us and enrich this fruitful workshop with your wide experience. شكرا لكم ونتشرف بكم دائما. السلام عليكم.
And now with the honoring ceremony, we're going to call names of the speakers. Please. Dr. Kathleen Draper. دكتور عادل عبد النور. الأستاذ الدكتور عبد رب الرسول عمران. دكتور ناصر عودة. للأسف شكله ما موجود معنا اليوم. دكتور باسل الهلالي. دكتورة أفراح الطيب. دكتور محمد الصيادي. ومن هم ليسوا معنا وجديرين بالشكر الدكتور خالد حسين والدكتور ناصر خان. في الأخير المهندس مقبل. صورة جماعية. صورة جماعية. إيه. طيب. وفي الختام نشكر لكم تواجدكم بناخذ صورة جماعية إن شاء الله. ناخذ من وقتكم شوي. تحت.